Please welcome to the stage Datadog Vice President of Technical Community, Jeremy Garcia.
Welcome, 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 and thank you so much for joining. It is great to be back in San Francisco. I've been here for a few days, and I have to say the energy is back. It's been absolutely amazing. And it's a great time to bring Summit back to San Francisco. Our second Summit ever was actually here. Really difficult to believe it's been 8 years since that last Summit. But also a fun fact, the only time we've done Dash outside of New York City is right here in SF. So great to be here. As that lovely voice said, my name is Jeremy. I'm the VP of Technical Community and Open Source here at Datadog. Just going to run you through a very quick intro, let you know what we have on offer today, and then we'll get to folks much more interesting than me. So what is Datadog Summit? It's really our celebration of you, our customers, our community. But what does that mean in practice? So we have a 90-minute keynote for you that is absolutely action-packed. We're going to have one of our product leaders join to tell you a little bit about why we started as an organization and what problems we're solving. Also let you know what products we're shipping and how we're enabling you to do your jobs better. And then tell a little bit of aspirationally where we think the industry is going and what some of the amazing innovation in AI may be able to unlock. We're also going to have builders from our product and engineering team join to tell you about things like LLM observability, Bits AI SRE, autoscaling Kubernetes, and some great customers like Glassdoor and UberFreight will join to tell you their stories of observability as well. We even have something for startups, so there really is something for everyone in this keynote. From there, 90 minutes, very dense, a lot to take in. We'll get you off to lunch where you can recharge, relax, and have a nice chat about what you've learned. After that, everyone will come back here to this room at 1 p.m. for a fireside chat with our CPO, Yan Bing, who's going to be joined by Aparna from Vercel and Hen from CoreWeave. This is going to be an amazing fireside, and I'm going to tell you a little bit more about it right before we head to lunch. From there, there's a bit of a choose-your-own-adventure situation where you can choose hands-on workshops, afternoon breakouts, or some firesides with the folks that are part of the keynote. And once again, I'll tell you a little bit more about that right before you head to lunch. After that, we're going to have you go to a networking reception. You've learned a lot. We've shared a lot. So we'll get to hang out, have some fun, hopefully have a laugh, and share some of that learning. We're here to learn, share, and grow together. That's what Summit's really all about. But wait, as they say, there's more. There's always more. Outside, you might have saw against the back wall there, we have some product demo stations. You're going to hear a lot about how we're using AI to up-level observability and security, but also to help you observe what is a non-deterministic system. You really want to see what that means in action, so join those demo stations for an in-depth walkthrough of the product. We have two really fun gamified experiences in AWS Game Day and Race to Resolution. Got to run through both. They're super fun. Highly encourage you to check it out. And then one of my favorite things about Summit is the quote-unquote hallway track where we just get to bump into each other, have a 5-minute chat, catch up. One thing that's always enjoyable to see is like two people that know each other that didn't know they were both Datadog customers. You'll see them start chatting, their eyes light up, they get into how they're using the platform to solve their problems. Amazing. That's, like I said, absolutely one of my favorite parts. And I'll call out the last one. Do appreciate that many of you are on call today. So if you do get a notification from Datadog on call, you have to go resolve an incident. Head to the on-call lounge. It's quiet, fast Wi-Fi. You get that incident resolved. Hopefully come back and share with us what you learned. That's what we're here for. For those of you that need Wi-Fi, I saw a couple people asking. It is on the back of your badge as well if you forget, but here is the SSID and password, SF2025. And with that, I'd like to introduce our VP of Product, Michael Wetton, who's going to tell you a little bit about the history of innovation at Datadog. Thanks again for joining.
All right. I can't see none of you. Those lights are so bright, but I assume the hallway's packed. Thank you so much for coming out, San Francisco. How are we doing? Yeah, let's go. All right. So, Mike Wetton, VP of Product. I've been with Datadog almost 9 years now. I joined in 2016. And at that time, we just had one product, and the company was smaller than this crowd here, right? But even then, in 2016, the company was already 6 years old. And the founders, Olivier Pomel, the one I think super stoked on the left there, and his co-founder, Alexis Lecoq, they had been peers at a successful education company called Wireless Generation. And one was VP of development and one was senior director of operations. And even though they were buddies, they'd gone to the same school, they'd done IBM together, now they're Wireless Generation together, their teams didn't get along. Dev and ops, it hadn't quite taken off yet, right? So, and I can relate, before Datadog, I was a developer for about 12 years, and there were times in which I pushed code and went to lunch, right? And then people try to call me and find me and say, you just took down 150 websites. What are you doing, right? And I'm like, that's not my problem, that's your problem, right? I tested it locally, everything worked great. So they said, if we ever build a company, let's do something to fix this DevOps thing. It was also early in the cloud story, so AWS had just started to take off, and they saw, oh, people aren't going to need as much expertise. Innovation, this emerging technology is really going to take people from idea to production scale very quickly. There's something happening here, and DevOps could be a real thing that as a developer, I could run my own services. And when I joined Datadog, it was the first time as a developer, I was expected to instrument my code, not only get it through CI/CD and into production, but now I couldn't go to lunch. I had to make sure my things were operating in the ecosystem, right? And so what is observability to them, to Datadog, right? Because it's in the DNA of the company, and it's really being able to answer for your service any of these 5 questions at any given time. And in order of priority, probably depending on how big your company is, right? Accessibility, sometimes people say availability, reliability, but it's really, am I up or down? Is my service even on, right? And this is typically where we get paged, where something really crazy is going on. But then security, compliance, performance is really about user experience, latencies, errors, and cost. Can I even afford my business? And we'll get into cost later because this emerging technologies, and this is happening, we're seeing now with AI, but even with the cloud, it enabled you to do a lot more, but you were moving so fast and the response from the market was so excited that you didn't have time to be efficient, right? And then the bills start coming in and you're like, oh God, we're not making any money. So cost for me is a key part of observability. They also realized that they would need a platform, right, across the entire software application stack. So when I started, we just had one product, which was infrastructure monitoring, right? But from the very beginning when I first started, they were already working on APM. They were already talking about log management. They were already talking about synthetics and RUM, even though they were years away from actually implementing this vision. From the beginning, they knew how to build software. They understood the components to understand, because a lot of times you might have your network and your infrastructure so instrumented, like you've got so much visibility, and then people are still tweeting your website's down, or I can't, and then the CEO might say, why didn't we catch this? Why are users still triggering our incidents, right? So this ability to instrument this whole stack that we were just looking at, in an old monolithic application in a smaller organization, not easy, but doable. But now, with the explosion of complexity, the cloud brought a lot of complexity, brought a lot more people into the conversation, a lot more technologies, computers being distributed. I see people installing databases on gas pumps now. It's bananas how distributed and chaotic the boundaries of technology are coming, right? And so this is only getting even wilder now with generative AI, in that now you have creative applications that can come up with their own hypotheses and ideas and respond to your users in ways that you can't anticipate. And so how do we manage this growing complexity? It's compounding, right? But here's the pitch. That's what Datadog is for, is to solve this complexity at scale. And I think at scale is a key component here. So as we've built out from infrastructure monitoring, the goal was always to cover the entirety of your tech business. And so to talk about how they're using the platform in creative ways to solve creative problems at scale, I want to welcome Srini on stage from Glassdoor.
Thanks, Michael. Hello and good morning, everyone. I'm Srini with Glassdoor Platform Infrastructure team at Indeed. Although I'm the only one presenting today, here's a picture of my team who's behind CI/CD and infra at Glassdoor. That's Andy, Ben, Will, and Shalini. A few of the folks might be hanging out in that corner, so save your tough questions for them. Now that you know about us, I want to tell you about the company we represent, Glassdoor. Our mission is to make work-life better together. We are probably known for anonymous employer reviews and salary information, but we are much more than that. We have evolved to be a community app with anonymous workplace conversations as well. I've also added some stat on our user traffic, volume of user-generated content, and number of employer profiles registered. All right, moving on. What's our setup like? I want to give you a brief overview on what Glassdoor infrastructure is like. We are a Kubernetes-first environment. Majority of our apps do get deployed to Kubernetes. I'm sure everyone in the audience here are using Kubernetes in some form as part of their infrastructure. Also, we developed a self-serve platform which lets our engineers to create, manage, and deploy apps to our cluster from GitLab. What that means is our engineers can request, change resources like CPU, memory, number of replicas that they need to run our Kubernetes cluster from GitLab CI YAML files. Not just that, all our observability needs are met with Datadog, obviously why I'm here today. And last but not the least, as I showed you in the earlier slide, I got a fantastic team to support this with. Everything worked great. The infrastructure worked, the tooling fit, and we are confident in our setup. But not until we got a message from our vice president saying, why is our infrastructure cost so high? That was a turning point for us. As much as we loved having a self-serve platform, which gave us flexibility and more control, but it came with rising costs. Yes, our AWS Kubernetes and Datadog cost was going up. We started seeing the number of nodes in our cluster were increasing. We did not find a good way to know where these costs are coming from. Why is our cluster size increasing? Nor we did have a way to translate those costs back to our service owners and tenants who are using our infrastructure. One thing was clear, our cluster was highly over-provisioned and not utilized as much as we like to have. Looking at what we missed, the message from our vice president was clear. It was not just a heads up, it was time for action. The very first thing the team and I did was to identify a cluster cost insight tool that gives us insights not just to us, but also to our engineers. That's when we partnered with Datadog to start sending our Kubernetes metrics to Datadog Cloud Cost. Second, we committed to ourselves saying that this will never be a one-time fix. We wanted to continue to improve and iterate. Third, we want to educate, empower our engineers with a cluster cost insight tool that gives them visibility to the service that they run on the infra and know how much it costs to run on infra. Most importantly, we want to drive this and use this opportunity to introduce a culture of shared cost ownership model. We figured it's best to do our homework first before calling in our engineers for help. As you could see in the graph here, when we started this journey almost a year back, our utilization in terms of CPU was 15%. And we looked into Datadog to understand our usage distribution across the board to see if there's an opportunity for us to reset some of our defaults in Java, Node.js, and Python, all the runtime that we have in our infrastructure. Then also we decided, let's change some of our autoscaler configurations. We had pretty bad configurations. For example, we had daemon sets that are holding back nodes just because it had local volumes attached. That didn't sound well to us. Maybe we thought, well, let's change things a little more. We wanted to try new autoscaler. We switched from cluster autoscaler to Carpenter, which did see some improvements, gave us a lot of flexibility in how we want to consolidate, how we want to improve our resource utilization across our cluster. Also, we started experimenting with some of bin packing strategies to move away from least allocated to most allocated to see if we can accommodate more pods and would that be more beneficial in terms of resource utilization. As you can see in the graph, this is a journey we have been taking slow, and I want to iterate and validate every changes that we move across. Make sure that we measure the impact and understand the trade-offs. It's not always about the cost. At the same time, you want to make sure that your performance needs are met. All right. We had some great performance improvements with changing our cluster autoscaler configurations or using Carpenter and even resetting some of our default resource configurations. But however, after a certain point, the improvements stalled. You know why? If you recollect one of my earlier slides where I said we gave the flexibility to our developers where they can change resources like CPU and memory and set how many replicas they want. Wasn't that a great idea? So we started leveraging Datadog to see if we can come up with a way to showcase our engineers how much their utilization looks like. So that's when we partnered with our DevX team who helped us to introduce workflows within CI/CD, which gives reminders to our folks when they deploy saying, hey, your utilization is 6.9%. You might want to consider tuning them. And we started nudging them towards dashboards in Datadog to see what does their utilization look like and where they have opportunities to improve. Naturally, questions did come up. What is the right size? How many CPUs to use? What's the memory to set? So we supported our team with workshops within Datadog, use training materials and documentation to make sure our team is more comfortable in right-sizing them. Once our team stepped up, we started unlocking those benefits. Here's the best part about that. We achieved a 35% in increase of CPU utilization across our clusters, which means our node count got reduced by 15%, and obviously it came with a sweet bonus of 35% in cost savings across our environments, which means happy boss, happy work life, which exactly ties to Glassdoor's mission of making work life better. It started all with us in infrastructure builds. Not just that, most importantly, we introduced a culture of a shared ownership. So it's not a one-way street. It's not just the platform team must own. Everybody should know what they're running in the infrastructure and know how much it costs, especially at this economic situation. And we started this journey out for saving cost, but we ended up enabling us with more budget for adopting new tools. So where do we go from here? Definitely we're not satisfied. We want to improve. So here are the next steps that we are looking to do. We want to move away from those reminders in CI/CD workflows and automate with pull request workflows that gives right-sizing recommendations to our team so that they can review and deploy. Second, now that Datadog is introduced an autoscaler, we want to do a POC with them and see if we can drive more value in dynamically resizing our cluster and resources and workloads. Third, it's been on my personal wish list for so long. We want to use SCADA for custom metric scheduling for applications that are not CPU and memory driven. Last, we want to advocate for Graviton instances, which AWS promises to have more savings and performance gain. So we want to strive to move towards that. With that, thank you. If you have any questions or want to share your experience, please do join me and Danny in the afternoon session. Thank you.
Hi, everyone. My name is Danny Driscoll. I'm a product manager for container monitoring and Kubernetes autoscaling here at Datadog. And I'm really excited to have the opportunity to follow Srini today because he has highlighted a lot of problems that we've heard internally from our own platform engineering teams and externally working with customers of Datadog container monitoring over the past year plus. So historically, the first really key KPI that I think would come to mind for many platform engineering teams using Datadog for container monitoring has been MTTR. How can we help ensure the availability and stability of the platform that you're providing for your internal teams? But as Srini noted, at Glassdoor, as well as at Datadog, cloud cost is really drawing even in many cases with that stability as an important outcome for platform engineering teams to drive and deliver. Finally, as we think about how we can deliver solutions for these problems, we need to be aware of how much direct toil time that might take from individual application teams, or how much other priorities the platform engineering teams can deliver on. So you need to look for opportunities to deliver on these efficiently through automation where possible. And so as cost has become a prominent focus for Kubernetes platform engineering teams, the idle cost of workloads and clusters is really top of mind. As you may have seen in some of our previous research reports, the amount of spend on idle compute in Kubernetes environments is as much as 80% at any given time across the Datadog customer monitoring base. So we're really, really excited to work with teams like Srini's and like with you all in order to help close this gap and deliver really significant cost savings for your organizations. As we've connected with customers over the past year plus, a few specific problems have really resonated in as far as what's blocking you from getting to those efficient Kubernetes cost outcomes. First, you need to be able to identify and prioritize where there's the greatest pockets of over-provisioning. Which clusters do I need to start with, and which teams do I need to work with first in order to deliver impactful provisioning changes at the workload level? Next, you need to be able to motivate or automate action. As Srini mentioned, they've invested in a lot of different activities in order to drive this, whether that's workshops, education, or eventually direct automation. There's challenges to being able to communicate and coordinate across all of your customer teams at scale to deliver these important outcomes. Finally, you also need to be able to evaluate and deploy new tools fast and safely. As Srini mentioned, when they were rolling out Carpenter, that's a significant change to make in your cluster. You need to make sure things are available and performant throughout any of those migrations. And then most critically, at the end of the day, you need to be able to clearly measure and communicate the cost impact that this is having on your organization. Ultimately, you want that credit and you want that ability to show your impact on the organization with these efforts. This is why we're really excited to have shipped Datadog Kubernetes autoscaling earlier this year to help solve a key set of these problems. For workload scaling, we provide multidimensional autoscaling, coordinating horizontal and vertical changes. We support fast deployment, either via the Datadog app or via GitOps with our Datadog Pod Autoscaler. And we allow you to prioritize, improve your impact with embedded cost reporting at the cluster and workload level. Walking through a typical workflow in Kubernetes autoscaling starts from our Kubernetes autoscaling summary view, which should be available now and visible in all of your Datadog organizations if you'd like to take a look at how much idle cost you have at the moment. We break that idle cost out into cluster idle and workload idle in order to highlight where you can start focusing first and show you those most over-provisioned clusters. From there, you can also easily visualize and hover to see which of your workloads are most over-provisioned at the moment and where you can start taking action directly at the workload level. And within that workload view, you can access a easily editable and inspectable scaling recommendation, allowing you to see the cost impact of different configurations for scaling predicted for this workload. And once you're comfortable with this configuration, you can easily click to deploy it directly from the Datadog platform, or you can configure a Datadog Pod Autoscaler custom resource to embed this as part of your Kubernetes platform within your GitOps workflows. So you have the flexibility to either act fast from within the app or embed this really deeply within your platform. Finally, as we highlighted, it's critical that you can show and demonstrate the cost impact of all of these efforts. What's the ROI on your time and your efforts in order to help drive down these Kubernetes costs? So working with Datadog Cloud Cost Management and custom reporting, we're able to allow you to show in a robust, consistent, shareable way how much progress you're making against these cost savings goals. So to recap, we're really excited to partner with platform engineering teams like Srini's and others to make this an easier set of problems to solve long term. If you'd like more information on Kubernetes autoscaling this afternoon, please join us for our Fireside chat or swing by the demo booth for more information. Thank you.
All right, you got Megan, continued product innovation. So we just talked about the history of innovation, which was really about how does Datadog build a platform. And when I say platform, I don't mean the box of broken toys that a lot of times people try to market as a platform. You know, Datadog, we did start as a data inspection company and then moved into alerting as customers said, actually, I want you to monitor my cloud infrastructure. That's where the real issue is. And the idea of being able to build something that we can continue to build a flywheel of product innovation on top of. Even when we do M&A, we've done about half a dozen deals over the last year, bought companies. When those companies join Datadog, they have to rewrite all their software from scratch on the Datadog platform so that it feels integrated, so that they're injecting the value and the expertise that they've built up over a number of years into Datadog so all the products benefit, right? And in some ways, that flywheel, while it took a long time of early investment, you can see it took a little while to ramp up. It's allowed us, these are just new products in 2025. It's allowed us to innovate very quickly. So that's one way in which we're able to scale product solutions very fast, to try to stay a little bit ahead of wherever you're at with what your company's trying to do. The hope is Datadog is there before you need it, right? So that when you're adopting these new technologies, we already have solutions. These are all, even just the first half of this year, all the product and features that we've announced, right? The other reason that we're able to move so fast is because we use Datadog. Our engineers are confident shipping maybe dozens of times a day across all the services with high confidence that things are instrumented. They'll be able to detect issues early and take action so that your Datadog, which is really in some ways a utility company for you, stays up and running, even with rapid innovation. So over the next 10 hours, I want to go through each one of these individually with you. And just kidding. I chose 10 of them, right? So in 10 minutes, I'm going to try to go through 10 products. We'll see if we can do it. Here we go. So the Datadog platform, we're trying to address the whole software delivery lifecycle, not just the application stack. So I want to start on trying to prevent incidents earlier, or going back into the whole shift left movement. How can we engage the developers, most of the engineering resources in your companies much earlier in the process? So the first thing I wanted to talk about was actually the MCP server, because it's had brought a pretty exciting adoption and pretty exciting response. So Model Context Protocol, for those of you who aren't familiar, is a new interaction method with intelligent systems. So more than just having to learn your APIs, it understands internal Datadog tooling and can interact with you in natural language or with your agents, right? So here we're looking at IDE, either VS Code or Cursor, but this has been so far the biggest reaction that we've gotten on the MCP server is just engineers staying in their context where they're working and being able to ask Datadog questions specifically around lines of code. How is this running in production right now? What are the latencies looking like? Are there any errors coming from this line of code? If I change this, can you help me understand what the outcomes are? This back and forth within the IDE has been incredibly powerful. And I've got a journal now of quotes of customers who've said, this helped me to resolve incidents faster. It seems to understand the context of my code, et cetera. It's pretty exciting. Next is internal developer portal. So really this is about standards and setting up as an organization, being able to personalize Datadog and have Datadog understand through observed state, help you to build a program of reliability and push that out to the whole company. So being able to develop golden paths, set scorecarding against teams and how they're adopting, from observed architectures and infrastructure and services to apply ownership, make sure everything's documented, make sure you have run books. All this goes into this, and even being able to do enforcement, so gating deployments when somebody's not, when a team hasn't instrumented their code or they haven't run security checks, all these types of things. Internal developer portal is really about pushing standards across the company. This one I'm very excited about. It's coming out in the next month. Datadog feature flags and experiments. This will be the first time on market that you can do automated canary deployments. So Datadog's feature flagging set feature will be completely unique in the industry in that it's informed by live telemetry. So the way that your production environment is working, as you go to roll out a new feature, I don't know how you do it, but when I used to do it, you can 5%, is everything okay? Okay, cool. 10%, am I in trouble? Anybody complaining, any errors, any tweets? No? Okay, just go 20%, and you're just waiting for the other shoe to drop. You get up around like 60, 70%, and you're like, I guess we're cool, let's go. And maybe some of you are more responsible than what I was, and you've instrumented or some of these things yourself with internal tooling. But this will allow you to start to ship things, and then Datadog will be able to help you make those decisions faster. Oh, we're detecting latency increases by comparative windows. Oh, we're seeing new types of errors because we have error tracking. We actually automatically cluster group all your errors. You should roll back. Or, hey, after 10%, this looks fine. Statistically, this is going to be okay. Go straight to 100. So really making your developers more confident to push code much quicker. All right. So moving over to the next section here, modernizing observability. So this is the bread and butter, right? How do we know when something's wrong? How do you get it working again? How do you learn from it and build more robust systems in the future? So, just a black slide. All right, I don't know what that is. But the first one I want to talk about, we're going to go more in depth on Bits AI SRE, so I won't say too much except for that this is an autonomous agent that can respond to alerts and do preemptive investigations and find root cause so that when you show up, a lot of times it's already found the problem for you. On the tail of that is our AI dev agent. The exciting thing about our dev agent is, we're not getting into general coding agents trying to compete with Cloud Code and these types of things. Instead, we have a unique opportunity that when Bits finds an RCA with high context, with a lot of investigation material already, Bits should be able to tell you what next steps to take and even generate the code. So generating Terraform or generating code that you can roll forward with because it understands the context and can even write the unit tests and things like that and deploy for you with experiments and feature flags. Next up, I want to talk about data observability, and this is interesting in that this is something that didn't even come up very often for me in conversations 2-3 years ago, but now it comes up all the time. Data engineering teams and data programs used to just support business intelligence or finance, but now things like Snowflake, Databricks, BigQuery, they're supporting production workloads and production business cases, right? So I had a customer who they had a massive campaign that they needed to launch on a Tuesday night to support some Netflix launch, I believe, and they had 2 windows. The schema had been finalized on Thursday, the previous Thursday. They had 2 opportunities to run this massive batch job to support the campaign. And it took like 24 hours to run. And a very expensive batch job failed the first time. So all hands on deck, every data engineer in the company having to respond, figure out where things went wrong, and then they only had 1 chance to run it again. Luckily it ran for them, but they were sweating. So they went to the SREs and said, what do you guys use to monitor things? Like, we never want to live that life again. And they said, Datadog. So all of a sudden, that was one of the first conversations I had about, hey, we want that same kind of tooling for data observability because now it's supporting production. And that's typically where Datadog comes into the conversation. So things like data lineage, end-to-end lineage, how the data is changing, data quality, data freshness, is all coming to market now. Storage monitoring, one of the key things with that as well is these are expensive. Like, big data programs are expensive. And so staying within your budget is increasingly a conversation that customers are coming to us with. We've had cloud cost monitoring for a few years now, but people have wanted us to go deeper and have more out-of-the-box views and insights on specific parts of their cloud infrastructure, and cloud storage being an easy one for us to iterate on. So here you can see all the data. Has it been accessed ever? What are the lifecycle policies? And what are recommendations that could save you a lot of money on data that's at scale, petabytes, sometimes in some customer cases, exabytes of data sitting in cloud storage, never getting accessed, not optimized. So easy savings there. And then the final one I want to talk about here is similar to the MCP, but in-app, a conversational approach for your responding engineers who are trying to troubleshoot things. Bits can read the screen. Bits understands your schemas, your context, and Bits is an expert on Datadog. Bits has consumed all the documentation. It's consumed a lot of session replays. It understands how people use Datadog to solve problems and can actually help you. So in this example that we're looking at here, here's a streaming platform that has a big event happening, has 5 or 6 CDNs running, and just anybody coming in without even having to understand the context or be an expert on how this company does streaming can come in and say, how is the general latency of my CDNs across them? And can you group them by CDN? And Bits is able to start having a conversation so you can tweak it and interact to get the answers you're looking for. So a conversational approach to investigations. All right, moving on into security. Look, security is your problem too, all right? And I don't know how many security experts, security teams we have out here, but if you're developing services, you need to be thinking about, are they secured, are they under attack, and be able to collaborate with your security teams in a way, because look, if security teams find an issue, a lot of times they come to you to make changes to your environment. And so it's good to be collaborating within the same environment. And one of the biggest issues that we've heard from security teams is the amount of noise. Security requires broad coverage, and you have to follow up on every potentially suspicious signal. And this requires a lot of human labor right now to go through every potentially suspicious signal that we might detect. And Datadog has a threat intelligence team that's writing a lot of these scanning rules and are world experts on cloud security, because we're servicing a massive part of the cloud security market. And so our internal threat intelligence team is also creating content for your security teams and for you as DevSecOps engineers. And we can reduce a lot of that toil. So Bits AI security analysts within our cloud team will actually go through and do a pre-triage on every single security signal that's detected, every single threat signal, and rule out maybe sometimes 80% of those, saving many, many hours of toil so that your team can really focus on truly suspicious and anomalous behaviors. So moving over to the user experience and the front end, many of you are already using RUM, and RUM is about detecting application errors and latencies on front end and mobile applications. One issue is that a lot of times these are consumer-based or high volume use cases. So even if it's not direct consumer case apps, right, which might generate millions of sessions, you might have running in like car displays within smart cars, et cetera. And so millions of cars, people interacting all the time. We have customers that have this use case. I mentioned before people doing smart gas pumps now, and there's media running there, and we're running their point of sale systems. So all across IoT, across consumer applications as well, RUM is trying to figure out how well that code is behaving. And a big problem has been visibility because the volumes are so big. So now with RUM Without Limits, you can send 100% of those sessions and we'll aggregate the most key analytics and trends off of those, and then we can store a representative sample so that you're not having to make those hard sampling decisions up front with head-based sampling. And finally, I want to talk about product analytics. Product analytics is about, if RUM is about application behavior, this is about your user behavior, allowing you to prioritize your business decisions by experiments and outcomes, and actually dive into, does the product intention do the outcomes of what my product was supposed to be doing, are they matching up? Are we making the right product decisions, right? And how is the things that engineers are building and changing all the time impacting our users, all right? So this is, again, breaking down more silos across the company. And this is all within one unified platform. So more to come. Again, that was only 10 of those many things that we were looking at. If you're interested in any of the things I talked about today, scan that QR code and we'll get you started. So, but to talk about managing cognitive load is Theo from UberFreight.
Yeah, fancy topic. So managing cognitive load today in AI-enabled observability future. We have been hearing a lot about Bits. We have been hearing a lot about AI in every tech conference and every tech presentation. This is not an exception. We have started using it. So engineers today, as the system gets more and more complex, they don't just fight incidents. They are fighting a storm of low-context alerts, disconnected data, and a lot of constant interruptions. Imagine getting 1,000 alerts. You've got to pick the most critical one and start addressing it. But now, with so many microservices, we are getting so fancy with our services. It's a lot of alerts. And we are not having a very good context on certain alerts. So that's what we are trying to solve. But during an incident, what do we actually do? The biggest question, where do I even start? When something is down, it's easy. I kind of like have my matrix, I go to top-down approach. But when something is slow, when something is degraded, we have this one big question. Where do I even start? The real cost of like scouring and scavenging to where do I even start, it's not just the downtime or it's not just the money that is spent. It's a lot of engineering effort that we put down during the time. And we all have promised SLAs to our customers. And the more times it occurs, it's a real cost to the business. So we started thinking, how do we solve? So before getting into this, I'm Tyagarajan Anandan. People know me as Theo because of my complex first name. So I'm a senior engineering manager, managing platform engineering for UberFreight, as it says. And we run a massive logistics platform connecting shippers and carriers. And we also have the same operational chaos and problems like every other company. So we started thinking, how do we solve this? So the goal is to reduce the cognitive load. So what's running in my brain during the first 5 minutes? What's running in my brain when I'm trying to like resolve an incident, when I'm trying to address this issue? So we started thinking a little bit different. So we want to shift the priority, or we want to shift the way that we are thinking towards observability. So imagine having 17 different tools to log in and 5 different terminals. We all have the fancy 3-monitor setups, but it's getting complex at some time. So we moved into more of like consolidation. We want everything into a singular tool. People might think cost, but it's nothing compared to the amount of time that you spend, the amount of time that you get to train and adopt on each and every single tool. So bringing everything into Datadog really helped. So we kind of like consolidated everything under a unified platform, as our favorite code as a single pane of glass observability. So that's where we went into. Without that, every single incident, no incident starts with good, but it's soon going to be bad and ugly. It's a very time-consuming process. So to do that, we started building a connecting tissue. Like we want to like put everything into a singular system. Yes, it's not just about like I have my real user monitoring here. I have my API monitoring here. My database team wants a very specialized tool that they want to do this. But having everything in one place solves a much bigger problem of finding overall patterns. Now I have all the data inside Datadog. Yes, I did the right thing. But what's next? having all the data is really unlocking the potential of Datadog? I don't think so. Tagging is a bigger problem in Datadog. If everybody have used in it, and the problem is not just cannot be solved by Datadog, it's our equal responsibility to do the tagging. We have all the tools. But I always felt the more tagging you do, the better we get out of it. Even before all this AI era, if you have the right tagging, you can easily create dashboards. You can easily create a lot of things. Your search is getting easier. So we started doing a very disciplined way of tagging. We put some effort in like making a standardized tagging. That helped us to give more context to the AI. The more context it has, the better result I'm going to get. I can have all the fancy bits installed and like started chatting about it, spending a lot of tokens, but am I getting the right information? But tagging solves the problem. Having a unified tagging builds that connecting tissue. And that's kind of like enables you to have the real power of the unified telemetry schema. So we build all this tagging, and what are we doing to go next? With this solid foundation, we get a head start on incidents. But we are really able to invest in the next generation tools to do something even better autonomously. So we found that the most critical part of the incident is the first 5 minutes, right? We are talking about it at like 5 a.m. or like 3 a.m. We all have this on-call setup. We woke up and like we kind of like, hey, join the call. Yes, I joined the call, but what's next? Like I have some sort of information, but we get more and more clarity. Every incident, every leader, every engineer, every business gets spooked of one thing: lack of control. We don't feel control during the incident. To feel control during the incident, we need more context. We need more context. We did this. I'm going to keep repeating this, like do more tagging, because you will see it as and when your data grows bigger and bigger, you're going to have this problem. But to win the first 5 minutes of the incident, you need clarity. And that clarity gives you control. And to immediately provide that clarity to the people who are just logging in, and ability to understand the overall context, you need a well-structured way of like approaching the incident with this. So Bits AI really helped us. The moment we started having the conversation, we put the tagging, everything in place, we kind of get like an initial, we saw that fancy map of like, that's a reality, guys, it's happening. So we have this in place. The moment we have that in, we kind of like get like good, hey, this is your service, and this is where I find the latency. We all seen this correlation feature in Datadog. And like you kind of like get like a mental map of where to start, what are the workflows, and how do we approach the problem from there. So yes, I have the tagging, I have the right things. Now I have this fancy AI, but what's next? We took like a slight turn when approaching the incidents and overall observability by introducing Datadog to completely non-technical users, to business, to ops, to accounts, to sales, everybody. This has enabled a lot of more meaningful conversation from non-engineering teams to the engineering teams. Instead of getting information from your VP of sales, like, hey, your system is always unstable. Now you have a data to back up. Hello, boss, look at the dashboard. It's there. And your account team is reporting. I keep getting calls from customer, and they're telling it's slow, it's not working. Instead of that, imagine they are sending you a Datadog URL. Like, hey, this is the particular graph, and this is exactly where it is. So we started having more meaningful conversations, saved engineering time. We also avoided a lot of void in the engineering time, like thinking, hey, my system looks good, but why not? So you're also upskilling people. Thankfully, Datadog is not user-based licensing. You can just like give it to 1,000 people, 5,000 people, how many ever people that you want. So that is easy. So we wanted to like up the game because of Bits AI. We started introducing Bits AI to our non-technical users. Our non-technical users, they could just go and log in. Hey, is my system ready? Like, what's my SLO on this particular service? Is there anything happening in production environment? We all have gotten this question. We're slowly turning the tables and giving this as like a gateway for our internal users to talk to us, to talk to Datadog. We don't even have to like build like a fancy list of dashboards or anything. As long as you do the right tagging, you have the right name, it can actually pick up the code and like gonna divert the users into the right phase. For technical users, it's much bigger advantage. That's where I'm really kind of excited about the Bits AI, the SRE style of agents. That's where we want to like slowly traject into. Like, what more that I can get in? Not all issues are surface level. There are going to be more complex and deeper issues that are going to keep popping in our systems. So I'm kind of excited about like what Tristan is going to share with us with the Bits AI SRE agent. And I just don't want the system to tell me this is the problem. I want the system to do something a little bit more. Can you solve the problem? Can you solve the problem? We all have the fancy runbooks. Now I give you all the runbooks. What are you going to do with the runbooks? Is there anything that you can do a bit more than just do this? So you all have this REST to resolution. I really suggest you to like go try it out and feel the pain of ours. So just to recap, one of the biggest job of any SRE or other engineers is more of like turning chaos into order. Tame the chaos. Build standards and fundamentals, most like tagging. You're going to keep hearing that. But anytime you catch me outside, we're going to talk about tagging much more detail. So standards and fundamentals and tagging is a continuous effort. It's a two-way street. We give more context to Datadog. We get more from the Datadog. And unify the context, the one we talked about. Empower all stakeholders. We might feel a bit wacky when we start, like, hey, are they seeing too much? Or they think you have role-based access control. Just like go tune your roles and open up access to more and more people and have more meaningful conversation, and that's going to be really helpful. It's a game changer. And investing in future. Sometimes we might feel tools are costlier. AI is costly. Do I really need to like go about it? But the value proposition is much more. Instead of looking at an unit cost, I always look at total cost of ownership. It really pays off. So I'm really excited, Tristan. So you're going to tell us a lot more about the SRE agent. Thank you. Thank you, everybody.
Thanks, Theo. I want to focus on a point that you mentioned about cognitive load. Observability has never been better, yet the job is not getting any easier. Systems are continually getting more and more complex. There's just more to look at and consider, and it makes it harder to make those critical connections to find a root cause, especially when you're on call. For example, 2 weeks ago, my team was paged for high Kafka lag. We pull up the dashboard, and sure enough, you see a big spike in latency. Now I'm digging through half a dozen dashboards for services that my team owns and services my team doesn't even own to find a correlation. It's a huge mental tax. But if we can bring in context to your environment, like Theo was talking about, and with AI, we can make those connections for you and quickly to help reduce that cognitive load. We first started solving this problem with our Bits AI chatbot. You could ask it questions about the health of your system and pull telemetry to help find a root cause. And it was great. But we quickly realized that agents were the next revolution for AI and observability because it allowed us to go from reactively answering questions to proactively collaborating with you. And that's why I'm excited to talk about Bits AI SRE, your 24/7 on-call engineer. So when your monitor triggers, Bits will proactively launch an investigation, look across your entire Datadog environment for signal, and then find the root cause in minutes. Using Bits is like having an engineer join your team who's already familiar with your system and is on call 24/7. But enough talk, let's see it in action. Let me show you how Bits can solve an alert from start to finish. So from the moment you're paged, Bits jumps right into action. This time, we were paged because an endpoint on our Flight Query API is experiencing high latency. Bits will start this investigation by gathering context about the alert from your Datadog environment, your runbooks, and from previous investigations, all in under a minute. And like you or me, Bits is pulling telemetry from your dashboards, metrics, logs, traces, and more. All right, now check this out. This is the really cool part. Based on its initial findings, Bits will create a variety of hypotheses to what could be causing the problem and then verify each one concurrently. With our latency issue, Bits is considering if the problem is caused by query timeouts, a faulty change deployed to the endpoint code, slowness in a downstream service, or a spike in query traffic. Bits will then evaluate each hypothesis using your telemetry to determine if it found the root cause, needs to dig deeper, or move on. For example, take a look at this branch. Here, Bits hypothesized that the latency was due to query timeouts. Why? Because of high DB load. Why? Because of increased request traffic. So unlike other agents, Bits is not a black box. You can follow Bits' reasoning every step of the way. Bits will then continue to drill down until it finds the root cause. And in our case, Bits determined that the latency was due to query timeouts from that branch we looked at. And right there shows you the power of the hypothesis tree. Bits is able to simultaneously investigate multiple chains of reasoning in minutes. You get a thorough investigation every time. And every step of the way, you can dive in and see all the evidence and reasoning that went behind it. You can also teach Bits to remember useful research steps and correct ones that weren't, so it's continuously learning. And just like a teammate, you can ask Bits questions about its investigation or get help taking action. For example, here, I'm asking who owns the flight database, so I can page that team in and get their help. Bits will also keep you up to date by posting its high-confidence findings back to Slack or ticketing tool of your choice. So there you have it, Bits AI SRE, a fully autonomous AI agent that's able to help you troubleshoot and resolve your production issues 24/7, so your engineers can focus on what's important. I also want to give you a preview of what's up next for Bits. First, we're having Bits find deeper root causes by expanding the monitors and telemetry it's going to look at. Next, we're going to start to correlate insights from across investigations to help answer that question of why you're getting paged week after week for the same thing. And then finally, we're going to start to close the loop by helping remediate issues by recommending code fixes and to run workflows. Now, before I go, I really want to highlight some of those best practices that Theo was mentioning earlier that'll help you optimize your environment, not only for Bits, but just for an AI in general. Firstly, you're going to want to make sure your entire stack is instrumented. Next, you want to make sure that you're consistently tagging your services and telemetry and that you're standardizing your tags across your entire organization because fuzzy mappings lead to fuzzy results. And then finally, you're going to want to optimize your monitors for investigations by including useful telemetry for the agent to look at and providing guiding instructions to the agent, just like you would any other teammate. So now that you've seen all that Bits can do, you can use this QR code to add Bits to your team today. And while we were building Bits, we had to experiment and iterate a lot. So to share more about our experience with LLM observability and some of its newer capabilities, I'm going to kick it over to Shri.
Thanks, Tristan. Hi, everyone. I'm Shri, a product manager here at Datadog, and it's great to be here today. So I know many of us have been working on large AI initiatives within our companies, and if you've been working with LLMs, we all know that they're quite powerful, but also pretty unpredictable. That's where evaluation and experimentation comes into play. They are how we can test changes to our prompts, our models, and applications, and make sure we are actually improving things. So with that context in mind, can I get a quick show of hands on how many of you here can say you've absolutely nailed your LLM evaluation process? Yeah, not a lot of hands, right? Because I don't think anyone here can actually confidently say that because it's so new and it's such an evolving science. But before I even go into why LLM evaluations are hard, let's quickly level set on why evals even matter. One, our models keep evolving. The last 2.5 years has been breathtaking in terms of the pace of innovation and the rate at which new models are getting released. With every new model release, these models are getting more powerful. they're getting more cost effective, or sometimes both. And that means we're constantly iterating, constantly testing and swapping new models, trying to see how we can evaluate and see which model is the best in the context of the application we are building. Second, our use cases are also expanding fast. As the models are getting better, we also want to push the frontiers of what our AI application can do. Many teams have launched AI products or AI features with one or two core scenarios, but the business wants more. New workflows, new customers, new user segments, new integrations, and which means we are kind of constantly iterating to see how we can improve and address these newer use cases. And finally, you need proof, data. When you tweak a prompt, swap a model, or change something in LLM applications, how do we know we're actually improving things? Without a solid evaluation process, you're leaving it to a lot of guesswork to make cost, quality, and performance trade-offs. We can vibe code, but we really can't vibe shit, right? And that is the truth today. LLM application development is extremely iterative, but without a reliable yardstick for improvement, that iteration feels a bit like chaos. So we know now that evals matter. We know we all should be doing it. But yet, I don't think anyone here can say we are doing it right. And that's because the entire journey is pretty hard. The entire process is riddled with a lot of friction in the process. For one, many of us may not have baselines or a benchmark for improvement and measuring ourselves. And we don't have a golden truth or a golden set of responses. Oftentimes, we're just comparing outputs based on gut feel and vibes. We may also be iterating blindly. We may be tweaking prompts, optimizing for a specific test case. But when we optimize for one area, it could be causing regressions elsewhere. And this is more common, especially with LLM applications, given they're so non-deterministic. And lastly, the testing is extremely slow, painful, and manual. Many teams are still cobbling together spreadsheets of prompts, golden responses, right, Jupyter notebooks, and homegrown scripts, but these do not scale, especially as the application grows and your user adoption is increasing. So to address these challenges, I'm now happy to announce that LLM Experiments is now available as part of Datadog LLM Observability. When we first launched LLM Observability, we were primarily targeting monitoring and troubleshooting use cases. Teams could trace their LLM calls, see token usage, latencies, debug errors, set up some pre-built evaluations, and keep an eye on their costs. This gave developers the confidence and the visibility to deploy and scale their applications in production. But what we learned from you, our customers, is that working with LLMs isn't just about monitoring. It's extremely iterative. You're constantly tweaking prompts, you're swapping models, adjusting your LLM chains and pipelines. And this iteration process up until now was hard to measure, but even harder to scale. LLM Experiments is designed to fill that gap. With the Experiments SDK, you can quickly run structured tests over your data sets, dive deeper to compare why one prompt is performing better than the other, compare entire experiments side by side, and make decisions on cost, quality, and performance all in a single place. LLM Experiments has three main capabilities that is designed to remove the pain from an evaluation and experimentation process. One, flexible data sets. You can bring in your own set of test cases into Datadog, define that as a data set within experiments. Or more importantly, you can even promote your production traces as test cases by adding them to a data set with a single click. This way, your data sets actually reflect the reality and what your users are actually seeing in the wild, versus a set of synthetic lab cases. Second, you can run structured tests over your data sets, compare experiments side by side, tweak prompts within a playground, add your own custom LLM evals, and submit your own evals as well, all within the experiments platform. This way, you're cutting your iteration cycle from days and hours to just minutes. And finally, and this is critical, we help close the loop. You can continuously monitor your LLM outputs live as they come in, apply the same evals that you used offline, catch any failures or anomalies, and these can then automatically flow into your data sets to act as new test cases for your next iteration loop. This helps accelerate your LLM application development cycle. With the addition of experiments to our LLM observability product, we now cover every stage of your LLM application pipeline. You can develop and make changes to your prompts, test and tweak your prompts within the prompt playground. You can now evaluate these changes, build your own custom LLM evals, submit your own evals. You can iterate quickly by running structured experiments over your realistic data sets, and then you can monitor them in production, all within the same product. And from production, you can then identify anomalies, failures, which then flow into your data set to help accelerate your next iteration cycle. This is a flywheel that keeps going faster and faster. Now, before I wrap up, there's one natural question, which is, how can I use LLM experiments more effectively? After all, tools are only as good as the practices and processes around them. While building LLM experiments, we had a chance to work with several leading AI teams, including our own internal teams, and we noticed some best practices when it comes to LLM evaluations. First, ship small, ship early. The easiest mistake we can do is trying to build a gigantic set of test cases that cover a wide variety of imagined hypotheticals. One of our customers, Whoop, is a great example. They started by testing small, developing focused data sets tied to their core user experience. This gave them the confidence to build quickly, but also expand systematically. Next, start with end-to-end evals. It's tempting to test components in isolation, but the real signal comes from evaluating your systems the way customers experience it. One of our best examples is actually a Bits AI team as well. As they build their AI agents, they focus more on making sure that the AI agent came to the right conclusion, rather than obsessing and writing lots of evals, testing the actual number of steps or the order in which the steps took place. As long as the conclusions were right at the end, you could then move on to a more pressing challenge. And finally, avoiding overspecificity. If you design your evals for very narrow use cases, you tend to overfit for edge cases and miss the broader picture. Keeping the evals a little bit more broad-based also makes them more resilient to changes to your LLM application, your prompts, or the different use cases that you're building for. One of our customers, AppFolio, adopted a similar approach based on their own learnings. Rather than writing evals to test for specific phrases in the LLM output for the AI chatbot, they more focused on whether the AI chatbot is answering the user intent and user goal. This allowed them to iterate faster as they expanded the use cases, as they didn't over-engineer the prompts, didn't really dictate within the prompts that LLM should respond this or that, and hence avoided a lot of refactoring cycles for them. And all these examples use LLM observability as part of their journey. And I can't wait for you guys to use LLM experiments as well. To learn more about it, do check out our demo at the demo booth. We also have a session later this afternoon, a Fireside with a VP of Vercel, V0, where we'll be diving deeper into rapid prototyping and experimentation as well. But before I wrap up, there are three main things that LLM experiments does. One, ground truths that reflect reality, iteration cycles that are cut from days to minutes, and the ability to decide with data, not gut feel. And you can turn any failures into production, into tests, and close the loop between development and production. So I've just talked about how we could harness the power of AI in a much more iterative and systematic fashion. Some of the best companies that do that today are a lot of AI startups, many of which we can find in the Bay Area as well. So to talk more about how Datadog is supporting these startups, I would now like to hand it over to Yashi.
All right, good morning, everyone. How are y'all doing today? All right. My name is Yashi Wu, and I have some big news to share with you about our Datadog for Startups program. Until now, our program was only available to companies that had raised up to $4 million in funding. but I'm excited to share with you today that we are expanding. We have eliminated the funding cap, so now all startups that come through our referral partners that are Series A or earlier are eligible to apply. If you're a startup, you're likely already working with our many VC and hyperscaler referral partners, and you can always check out our website for more information on that full list. So why does this matter? What do founders and teams even get when they join Datadog for Startups? Well, first off, you get an entire year's worth of access to our platform with up to $100,000 in credits. That means you can use everything Datadog has to offer while you're building, including LLM observability, which you heard Sri just talk about, plus product analytics, real user monitoring, error tracking, and a whole bunch of other amazing products and features that you'll be hearing about today. On top of that, you gain access to hands-on technical enablement to help you get started quickly, and you can join our Datadog for Startups community, where you can connect with other builders, get product updates, and get events to catered events for our startup and developer community. So let's give you an example with Patronus AI. When they came to us, they were struggling with fragmented observability tools, manual instrumentation overhead, and excessive error noise. With our startups program, we enabled their 12-person engineering team to quickly replace a bunch of different tools, and that dramatically improved their debugging capabilities, because now, as you know, engineers could quickly pivot from log entries to distributed traces and be able to quickly identify the root cause of errors and performance issues. On top of that, our Datadog APM auto instrumentation allowed them to automatically capture API calls, database queries, as well as service interactions with zero, I repeat, zero code changes. This means their engineers could focus on what really mattered, which is delivering new product features. So our unified platform helped them accelerate time to value, reduced operational overhead, and create a foundation for real growth. With Datadog, we believe startups can not only ship faster, but they're also building trust, resilience, and a lasting competitive edge that will grow and scale with them as they continue to define the next generation of category leaders. So, if you're a startup, or if you know of any startups, and come on, here in SF, how many of us don't have some startup friends? Or if you'd like to become a referral partner, please come find us. Please scan our QR code. We'll be on the expo floor, and we can't wait to work with a bunch of you. Thank you so much.
All right. Y'all still with me? Yes, no? Y'all still with me. It's okay. Let's bring it home. All right, so I'm doing a little bit of like a Christmas Carol thing. We did the Ghost from Christmas Past, and then we did present. Now, a little bit of future-looking things for Datadog. It's essentially, where do I feel Datadog could go with the opportunity we have in front of us? How might that benefit you as you're trying to also accelerate? Growth in the AI space is compressed. When I joined Datadog in 2016, I felt like we were already moving at a breakneck pace, and all of our peers were moving at a breakneck pace. And that's just compressed. You look at the startups now and what's expected in the time that they're working and the adoption of their tooling. Just the innovation, the emerging technology has shortened even more that time from thought to scale, right? And Datadog's trying to stay, again, ahead of the curve there so that when you get to that scale, we already have these new emerging problems. As Sri was talking about, evals, making sure that your AI can demonstrate core competencies before you put it out in the world for your use case, as well as experiments, are going to become increasingly important for any of you here who are trying to build new AI-enabled applications. And I've already seen, and I predict more in the future, new types of incidents with your AI going wild in production, right? And doing things that you didn't expect it, and being able to have to iterate on that super quickly and make corrections. And so how is Datadog's AI platform going to address these needs as we go forward. So first of all, we have a unique opportunity in that we have a core competency and we have all the right data, trillions of metrics, trillions of logs, complete architectures across many tens of thousands of customers. So if we look at all of our customers and all the architectures they're running across cloud providers, it's not 40,000 unique architectures, it's probably in the hundreds. And even if you're not perfectly instrumented, we saw from what Tristan was showing, Bits can make inferences about what it expects because we understand the cluster groups of architectures, that even if we don't know exactly what you might have deployed in some cases, we can make pretty intelligent inferences. There's human-like reasoning and thinking there to say, oh, well, we can't see everything here, but most people who have your similar architecture at your scale and traffic have a firewall here, and from what we detect in the signals, it's most likely something over here. And that is what the emerging technologies is bringing for us as well. We also understand your organizations, how you name services, right? So things that are very specific. We can not only have deep specialization in how cloud software works, but we can start to move towards personalization about how your company works as well. And bringing these together enables us to do more. Now, it takes a lot of investment, and we see the numbers out in the market of how much people are investing in AI. That's not slowing down here. 30% of our revenues we put back into R&D, which is unprecedented in the market for among our peers. Here we're looking at Toto, which is our time series predictive intelligence model. Is state of the art, and we continue to invest in this. And what it means, again, is this new emerging technology. What it is with less context, being able to make correct inferences about the state of the world and what actions you should take to improve your user experience. And so this one is time series, but we have lots of unique data at scale that we can use to help you even when you're not perfectly instrumented. The reason I wanted to talk about that is that slide that Tristan showed about get ready for Bits, make sure you have all your monitors, make sure everything's tagged, make sure everything's instrumented. Oh, that just drives me nuts, right? Because yes, that's what you need to do now, but in the future, that's not how it should be. You shouldn't have to be perfectly instrumented and an expert in Datadog and set up your monitors in order for the inferences to work, and we'll get there, right? But we need to learn and work with all of you. So Joshua was just calling out lots of startups using Datadog now, and we're learning how they're trying to build these new products and where it's working, where the technology is working, and where it still needs to progress. And they're living the world forward, and we're working with them to do that. We're also working with the largest at-scale AI companies to figure out where the AI works at scale as well and what problems they have. So we try to make sure that we're staying at the bleeding edge of both scale and go-to-market. So here's my controversial pitch for the keynote here. Is there a world in which you could have zero incidents? I said earlier that the reason Datadog was able to innovate so quickly is because we're using Datadog and our engineers can push code quickly with confidence, right? But we've been using Datadog since it started, and so we've grown up with it, so we have a unique advantage there. How can we make every company work like that so that you can just focus on innovating, right? In that time of creative idea to safe scale, safe, secure, compliant, cost-efficient scale is just seamless, I think it's a possibility. And I know of anybody here who's old school SRE and familiar with the Google SRE handbook, it says, don't even try for zero incidents. Because what they're saying is when you try for zero incidents, the easiest way to do that is to stop innovating. Just don't change your environment. It'll never go down, right? But I do think we can introduce a lot of change, a lot of risk without bringing down production. And so this is the flywheel we're building. And to get rid of Tristan's slide, it means Bits is going to have to learn how to dynamically instrument your code when it needs. So you don't have to just have stuff logging all the time, which is super expensive, and only getting our customers' logs have grown 2 to 3x just over the last 12 months, right? And that's unsustainable. How can we only gather insight when needed in order to make decisions and make those decisions count? And I think there's a world in which we're starting to evolve in that way, where Datadog can monitor for stress in your environments, set your SLIs and SLOs for you based on the benchmarks we see of the data flowing through these architectures. And then when something seems stressful, figure out what effectors you need to take and keep taking that action until the system is back into a stable state. Now, single service automatic detection and response is pretty close. Bits SRE and Bits Dev Agent, for those of you who already have it enabled and are using it and giving us feedback, is actually doing some pretty amazing things. Where it gets a little more complicated, and where I think our next investments are, if you were at Dash and you saw our voice agent or our incident management agent, is any real serious incident is multi-service, multi-team coordination. You have to take multiple actions in tandem to bring the system back into a healthy state. And that requires us to learn a little bit more how teams work together so that agents can also work together across complex multi-service incidents. So this is where we're headed now. Our voice agent that we're working on will be able to join your Zoom bridges if you want, be able to listen to multi-conversation and lurk Slack and figure out who's talking about what, who's right, who's wrong, and start to contribute to that conversation, and then also be directed to take action. And we're already seeing in some very specific verticals, like we saw with Kubernetes, autoscaling, Datadog can actually feel confident running some of those operations maybe better than a person could. So that's, do we have a slide here? Here we go. So that's my hope for the future, is that Datadog can continue to help you and your teams operate safely at scale, regardless of what the technology is bringing and the pace of technology and innovation, that our core value proposition of bringing more humans into the conversation to build creative solutions for human problems, Datadog can be a core component of that. This is my personal, or not my personal, this is my work email. Not too different than personal, you probably guess it, but that's my work email. If you disagree with anything I said, or you're interested in the products, you want us to build something that maybe we didn't talk about, or you have creative ideas, shoot me an email. I'm happy to engage conversation with any of you. I see some of you taking me up on that already, taking pictures. Go for it. I'm serious. So thank you very much. I'm going to throw it back over to Jeremy to see us off. Thanks.
Wow. I know I learned multiple things, and I hope you did as well. So a huge round of applause for all of our speakers. And thanks again to Srini and Theo. Really do appreciate you joining us here on stage. For those of you that haven't emailed Wetton yet, please get on your phone before lunch. Just do it. Exactly. So I do appreciate that I'm standing in between you and lunch. I will be extremely brief, but as promised, wanted to cover what your options are after you've eaten. So 1 o'clock in this room, AI has clearly generated a ton of interest, but it's also raised a ton of questions. And here to discuss those questions, we have our CPO, Yan Bing, Aparna from Vercel, Hen from CoreWeave, 3 truly visionary, and I don't say that lightly, product and engineering leaders who are going to help you navigate what AI means. What's interesting here is there are 3 pretty different parts of that stack. I had the pleasure of joining the call to set this up, and I'm excited to be in the audience. It's genuinely going to be amazing. This is a cannot miss Fireside. From there, as I mentioned, we're going to have a little bit of a choose your own adventure with 3 different options. The first one will be in this room. It'll be the breakouts with customers like Mux and NVIDIA and Cambia. We'll have data observability and open lineage. We've talked about the importance of data in the concept of lineage a little bit today. We'll cover open lineage, we'll cover data pipelines with Metaplane, and we'll have a panel on RUM and what that offers for you. We also will have some Fireside PM chats with the folks that you saw on stage today. If you are interested in what they're saying and you want a little bit more in a more intimate setting, highly encourage you to join these. And we also have workshops. These are in-depth, hands-on. We drop you into a Kubernetes cluster, we drop you into a real Datadog account, and this is applied, practical, hands-on learning with everything from open telemetry to building a real, tiny but real LLM application to scaling Kubernetes and distributed tracing as well. Datadog certifications. Now this is a great way to up-level what you're able to do with Datadog. And as a thank you for attending today, everyone in the audience is going to get an email after the event. We're going to give you one free exam, absolutely free of charge, no strings attached. Pick whichever one you like. People are excited. The exams are great, so highly encourage you to take advantage of that. And lastly, if you've liked what you've seen and heard today, if you liked Datadog Summit San Francisco, you'll absolutely love Dash, which we're bringing back to New York once again, June 10th. We'll see you there. Hopefully you were in the audience last year, but if not, please do join us next year. And with that, again, what I love about Datadog Summits is it gives us the opportunity to share. We've all learned so much over the courses of our career, and we truly are better together. So share that knowledge, learn together, let's all grow, have fun. Thank you.
Please welcome to the stage Datadog Chief Product Officer, Yanbing Li.
Good afternoon. How's everyone doing after lunch? Thank you for coming back. I know, after that wonderful lunch and this morning's super information-dense keynote, thank you for staying with us. I'm super excited about this upcoming Fireside chat with Han and Aparna. So before I speak too much, let me first welcome my co-presenters, Han and Aparna, up to the stage. All right, so I'm Yanbing Li, Chief Product Officer at Datadog. So I think lots of you already know a lot about Datadog, so I'm not going to belabor the introduction about myself. Let me put the focus on our co-presenters. I'm actually really excited because I have worked with Han and Aparna at Google Cloud many years ago, and this is kind of our first reunion after we all left Google. It's interesting that we did a lot of work at Google together around cloud native, building cloud native infrastructures and applications, but now we're reuniting in this AI intersection around, again, AI infrastructure, developer experience, and observability. So, and we're going to get into all of that. Let me just quickly introduce the two speakers. I think Aparna and Han, I see them as queens of Kubernetes. I don't know if you guys have been in this ecosystem, you know their influence and impact in this space. And they have led product and engineering for Google's efforts around Kubernetes and serverless, and among other things. So after leaving Google, Aparna joined Pear VC as a partner specialized in AI and ML, investing and advising startups in the space. She also worked at Capital One, leading the AI efforts there. And now she's an SVP of product at Vercel. And we're going to hear more about her Vercel story later on. Han joined CoreWeave after leaving Google as the SVP of engineering. And she's led significant growth at the company, through the IPO journeys and, also M&As related to weights and biases, and more recently, OpenPipe. So, Aparna, Ken, welcome.
Thank you so much.
Thank you.
And maybe I'll invite Aparna to just introduce yourself a little bit more, and especially what you're doing at Vercel.
Yeah, thank you. Thank you so much for having me. It's so special to be with these two. We had a wonderful time in Google Cloud. And Vercel is really, we call ourselves the AI Cloud. It started as an open source project called Next.js, which was for developing web applications, and then became a developer service to host those applications. So very similar to our Kubernetes journey, which started as an open source project and then became actually a very large hosted business, not by itself. Of course, a lot of work went into that. And because Vercel is a developer-centric platform, really we started using a lot of the AI technologies internally, started using it for generating code, and out of that came this vibe coding solution called V0, where anybody can write code and deploy an application, and also a lot of internal developer tools that are based on AI. And so we then externalized a lot of that infrastructure into what is now the AI Cloud. So we offer a gateway, a way to build AI workflows as agents and so on. That's pretty recent. And in fact, I was involved in launching the AI Cloud, I think the week after I joined, which is just about 3 months ago.
Yeah, congratulations. Yeah, Han?
So for me, I feel like very fortunate to be part of that Kubernetes journey. And part of the thing that was really unique about that time is that, back at Google, we were thinking about how to disrupt the space of cloud computing, in essence. And the idea was really to think about what's now is going to be possible. So that's been an amazing journey. And I didn't think I'm going to have an opportunity to do something like that again. And then when working on something like, we've been starting to see a lot of AI workloads, I think being an infrastructure was never as cool as it is right now. So, the opportunity to, again, look at things like performance and throughput and just a lot of things that we've became taking for granted is really interesting. So I've decided to join a company called CoreWeave, and fundamentally we believe that we are at a time that will require us to re-platform everything we're doing. We'll have to change the ecosystem, the tooling, and the journey that we are on is reimagining how that will look like, and really making a lot of decision of how the entire stack from the bottom up is going to look like. It's been an amazing journey, and that's it.
That's great. Maybe let's continue on the point of that amazing journey. You talk about why the AI infrastructure at scale needs to be different from how we build the cloud infrastructure. How the neo cloud needs to be different from the traditional hyperscalers. Mm-hmm. Can you give us more insight on what are these key differences and what are also the key challenges that arise with these differences?
Of course. So first of all, when we think about the workloads themselves, okay, you can think about training and inference and now agents. There is a certain new set of requirements that come to play. For example, the amount of memory, the amount of network. Those workloads are actually usually do not reside on a single node, right? We're actually talking about those really huge clusters right now, especially when we think about model training. Even when you think about from an operational perspective, and I'm sure you guys are seeing that at Datadog with your customers as well, is that even the way we measure success of these workloads is changing. Okay, we're talking now about price per token. We're talking about MFUs, model flops utilization, like how much is the system. What does MFU mean? It means that I'm measuring how much the GPUs are actually doing the right effective work, like making sure there are no bottlenecks around the storage. Why is that important? Because, of course, everything is so expensive. Or even things like good put. Okay, we haven't used to talk about how much every single node is up and running, the cost of checkpointing. So there's a lot of new things just from those set of workloads that are coming to play. And then to add on top of that, I think the two things are also very interesting. One is that the technology keeps changing a lot. Mm-hmm. And that's maybe something that, I think in a much smaller volume we saw it in Kubernetes, but the technology and the complexity is really increasing. If you've watched Jensen's in his keynotes in GTC, he talks about all the components, right? How many pieces are in these huge racks? And how much power they consume. And maybe the last point I will say that with all of that complexity and all of these new requirements, what customers and developers want is still move as fast as possible.
Absolutely.
Right, and achieve that velocity. And it's actually a really hard problem to solve.
That's great. So the the new complexity in the infrastructure, as well as how developers still need to move fast, and certainly on the infrastructure side, as part of Datadog's efforts, we are looking at the end-to-end AI stack monitoring, including at the infrastructure level, at the GPU level, mm-hmm. Monitoring exactly what you highlighted as the challenges around, congestions and costs and utilization, et cetera. So maybe since we're talking about the developer experience, let me move to Aparna. You've certainly Vercel catch the attention and imagination of lots of the developers. But whether it's from Vercel's perspective or from what you see industry at large, what are some of the key challenges or changes around developer behaviors and expectations and their expectations for the tools they want to use to help them being better developers?
Yeah, I think that the life of a developer has changed significantly due to AI. I mean, engineering is one of the functions which has been most impacted by AI. I would say that developers are now able to move much faster than even when we were working on Kubernetes. I remember thinking that, well, Kubernetes is just automating the infrastructure, so it just automatically configures and sets up the infrastructure for the application. But what if we could automatically write the application? And this was like maybe 10 years ago, it was kind of a dream. Now AI writes lots of the application, and so most developers I know are using AI-driven tools. Certainly we are using them all over Vercel, and most of our customers are using these tools as well. And it's for everything. It's for certainly, checking your work. We have PR review, and it's for generating entire, whole applications. I think it has definitely made the developer lives easier, but also I think there's kind of a different workflow almost emerging with that. And as we play it forward, when there are more and more agents, we like to say there's an agent on every desk. And that's not just for developers, but there are more and more agents to choose from and to use, setting up your workflow in a way that, you're accessing the right tools. And you've sort of written the right prompts for these tools. That's important. The other thing, I think you asked about challenges. I think there are 3 challenges, and one challenge is actually keeping up, because there's always great models. I mean, like, I think last week, Thursday, there was a new model, and then Friday there was an even bigger 1 trillion parameter model. And because we are in the business of hosting an AI gateway, we have to be, we count the seconds till when the model is released till when it's available in the gateway. Because if you're off by 5 minutes, then you're kind of yesterday. No one cares. It's not news anymore. So we have more than 100 models to choose from, and part of it is not a different model is good for different things. So choosing the right model for the right task at the right time. So some of the technology that we've built, and there are others, of course, is automatically routing to the right model for the right task. That's part of the AI Cloud initiative. And then I would say 2 more challenges. One is on security, and hopefully we'll talk more about that. I'll come back to it. It's a major challenge. And the other one is on efficiency. And the efficiency piece is, for example, if you're building an agent or a chatbot. Chatbots are kind of yesterday now. People are building agents. If you're building an agent and you have to, and this is an infrastructure challenge, that agent is running on some infrastructure, often the agent is waiting on the model or potentially a human on some input. So if your infrastructure is just running during that time and you're paying a bill, that's kind of inefficient. So we've worked on, and I think others are working on, infrastructure that's much more efficient for agentic workloads.
Okay.
Kind of only charge when used.
So efficiency, security, as well as the the ever-changing landscape of AI and new models, new technology, new everything all the time. So maybe just to build on top of that, Han. It's interesting, as we think about CoreWeave, it was very surprising, actually, when I finally hired you, because I was thinking they would be hiring people that really build, infrastructure at a much more closer to the actual hardware level. It's interesting to hear about the investment in the software stack above that. So what does that modern AI stack look like in the context of what you guys are building in CoreWeave? What are these different layers, critical components? I know it probably will touch upon things like, observability, security, and many of these challenges.
I think that the one thing that how we approach it, I think it would be 2 things. One is really being customer-centric and understand what do our customers need and want and what they care about. And the second thing is being ready to challenge the status quo. Okay, can we do that? Why not do this? I think having those kind of questions really helped us just how we approach the problem. And I will give you a couple of examples. So one, for example, what do customers want? Okay, so one thing that we've invested a lot in observability is understanding that in order for you to move fast as a team, okay, I need a couple of things. One, as a developer or as an ops person, I want to have the data. Okay, I care about that transparency. I want to know what's there because, again, actually it's something we used to talk about in the context of Kubernetes. Having the data empowers me to take actions, to make the right decisions around my platform. So an area that we've really invested in, actually across the stack, we're not thinking about the cloud as layers anymore, but we have something that is like the brain of our platform, which we call mission control, where we bring data from all the layers. Okay, so in one view, we know what jobs are running, what resources they consume, but also what's the temperature of the GPU, and what's the network latency, for example, and just bringing all of them together allows us to not only take actions on behalf of our users, but also make that available for them, right? So if I see my job, for example, stuck, I know whether I need to restart it, I need to do something else, maybe open a ticket. And so that's like really one example. The second one, which I was excited about, again, about challenging the status quo. Today, all the hyperscales have the hypervisor, right, the virtualization.
Yeah.
Why does it make sense for traditional workloads? Is because you use a lot of oversubscription. Okay, you're using the same platform, the same compute for different type of workloads. You actually don't care what's happening under the hood. However, when we are coming to optimize for performance, well, it was a heated debate, you can imagine, internally. We're like, okay, what if we don't use hypervisor? What would that look like?
Yeah.
And those are just like example of some decisions that we've made. And maybe the last point, like why they brought someone like me at the scale that we operate in. I don't think you can do, you have to really rely on things like automation and Kubernetes and thinking about engineering excellence and operations excellence. And that's an area where I've been investing a lot in.
Yeah, that's great to hear. I definitely see, you guys have consciously made the decision to go bare metal versus, having that layers of isolation with a hypervisor. Yeah. So Aparna, maybe going back to you on, again, whether there is this new emerging AI stack where there isn't, it's much more fluid, as Hen described in her mission control. What do you see? You mentioned security. What are the key attributes or tools that's part of the AI developer ecosystem?
Yeah, I think there is an AI emerging stack. And, before Vercel, I was at Capital One, which is a large bank. Every enterprise is trying to enable a platform that their developers can build, internal agents or multi-agentic systems on, because there's so many opportunities to automate all these processes in the enterprise, whether they're customer support or engineering or finance, so many processes. So there is an emerging stack. And a few parts of that stack that I would call out. One is obviously there is a large language model or several large language models that, you need some sort of router or gateway to get those models into that platform. And you want to do things like, looking at the prompts, seeing if there's, some sort of security or cybersecurity concern with the information that's going into and out of the model. So that's typically a gateway function as well. You want to log all of that information. You want to evaluate the performance of your system. Those are all things. Aside from the model, and obviously that model is running on some infrastructure somewhere, which could be your own infrastructure, could be a cloud. Aside from the model, there's usually some sort of orchestration technology that you're using to build this agent, which is going to be calling different tools. And those tools, there's an emerging standard called MCP, which is for, calling those tools, certainly in the sort of internal enterprise context. So I think that's some of the basics of the stack. And then at a higher level, there are a number of application SDKs, application development SDKs, and some UX patterns, some of which we contribute to. So back to our open source experience, Vercel has the AI SDK, which is a TypeScript SDK for developing chatbots or developing agents. And it tries to be very simple, and it's fully open source. There's a large ecosystem of many other companies that are involved in that. and then like a recently added UI or AI elements layer, which sort of like helps you build these interactions. So there's a lot of innovation in, how do you build an AI interaction. On the security side, so these are some of the elements, the application layer, the model and the orchestration layer. On the security side, you have to secure the access to the tools through MCP. That's very much an emerging area. You also, these agents themselves, they have to be, because the agents are going to do various things. Maybe they will crawl the web. You have many agents that are crawling the web. Maybe they'll take certain actions on your behalf. So how do you authenticate these agents? How do you know that that is an agent that should be coming to that particular system or to that site? And so at Vercel, we host a lot of sites, retailers and gaming companies, all kinds of companies. There are certain agents that you want to accept and certain agents you don't want to accept, right? Like certain agents that are going to maybe crawl your site and then help you make a sale, but other agents that are crawling you to copy you. So there are new standards that we're working on to authenticate these agents. Those are some of the, and then of course there's a lot of malicious agents, so to recognize and block malicious agents.
That's great. And you guys are building those tools in-house, or are you also, you see promising technology, vendors emerging, building those, as third-party tools?
Yeah, most of the work we are doing as open source. Certainly,
Okay.
The AI SDK is fully open source. The AI Elements is fully open source. The bot auth standard, web bot auth standard. This is an IETF, Internet Task Force that we're working with. What we do at Vercel is we create our own directory of agents. We have a firewall and a CDN, which when you host your application on Vercel, protects your application from bad bots. And it's customizable, so you can say, I want to be scraped by OpenAI, but I don't want to be scraped by Anthropic or vice versa.
Yeah. That's interesting. I wonder if you've seen recent pattern change on the applications that get created and hosted on Vercel. I was trying to convince one of my kids to play with V0 or Lovable. She studies design, but I'm trying to get her exposed to vibe coding. I'm wondering, with the popularity of things like V0, but also people building real production apps, how that's changing the pattern of what the Vercel platform is seeing.
Yeah, we have seen exponential growth on V0 for vibe coding users. So we deploy 6.5 applications per second. Okay. 6.5 applications per second, and growing, based on this. Some of the things that we've tried to do there is really make sure that those applications are secure. Mm-hmm. And so a lot of checks go into it. We focus especially on Next.js because that's our framework. Because again, like vibe coding can be dangerous. Like if you're putting an application in production that hasn't gone through all of the proper security checks, and so V0 actually specializes on the security aspect of it. But we've seen phenomenal growth, and it's developers, but a lot of non-developers. It's designers, actually, quite a few UX designers and product managers.
We see a lot of that for sure. I think that what's become the most important part of that application development is actually the data and understanding the data and what data you want to bring from the different tools to create those kind of new applications. So that's a pattern that we start to see. And also, I'm really excited with how accessible the technology is becoming. And so when we're looking, we have a part of our portfolio, we've acquired weights and biases, and model is actually used for training. Yeah. And I think there was some thoughts like, hey, only few were going to be doing training in the industry. But then technologies like reinforcement learning came about, and it's really changed the way application is being developed or reasoning models. So we just actually saw like an increase with the folks that are investing in training, and also back then the amount of inference, and how does that look like?
Yeah, that's interesting, because I know as an industry, we've been also watching just AI infrastructure or GPU usage when you cross over to be training dominant. People operating these huge GPU farms who now starting to see, inference become a dominant part of that usage. But what you're saying is training is back. Also because more and more people are.
First of all, the minute that the technology is more accessible and the tools become better, then people will have more use cases, right? So we will see that growth. The other thing is, we talked about tokens before. So it's true, by the way. I think that the idea that price per token is going down is, again, reducing that barrier to entry. Right? If the cost of that is going down, actually more people will be able to leverage the technology. And then the new AI technologies that we have, like reasoning, like reinforcement learning, creates more token. But also, we talk a lot about, from AI development, we talked a lot about quality or accuracy. And that's becoming also critical for that AI development, and there's a lot of use of infrastructure for that. So definitely, not going into numbers, we see demand continues to rise. That's definitely will continue a challenge for us as an industry. To improve efficiency, but also meet the demand of infrastructure.
Yeah, one thing I would add there, I think accuracy, like we have seen just over the last 2 years, a real evolution in how AI applications are built. They started with, and there was a lot more emphasis on sort of single model to begin with, and then retrieval augmented generation to get, minimize hallucinations, which I think was maybe 80% of the solution. But the reason I think why agents have emerged is because it actually improves your accuracy much further to have multiple models, specialized models for specific tasks, and to be able to call tools for things that don't necessarily require a model. And I think the developer workflow is the prime example of that, of that sort of cutting-edge AI application, which is an agentic application. Like V0, for example, is an agentic application, and it calls certain tools under the hood, and it calls certain models, and which model it calls for which task depends on whichever model is the best. So, and those models have evolved in that they are, of course, much more capable models, but they're also doing a lot more reasoning, which is very useful in the coding task. And many of them are trained, and then they've had the post-training and reinforcement learning specifically for specific programming languages. And we certainly help with that. Vercel helps. We collaborate with OpenAI and Anthropic and Gemini to do the evals and make those better.
Yeah. So speaking of the advancement of agents or applications, this morning we shared some of the Datadog agents, such as our SRE agents. We shared our LLM observability capability in eval and all that. We definitely see the advancement of these agent performance is related to both the advancement of the model, the quality of the data, the quality of the evaluation, and we've definitely seen that strong progressions of the quality of results because of those factors. Maybe coming to the evaluation topic, this morning the speaker asked the questions of who feel they're doing great evaluation, and I think nobody raised their hands. So Han, I think both was with some biases. I know this is a huge focus for you guys, but what's your point of view? What's state of the art eval look like, and how do people get there, feel really good about their eval?
I think that as we think about like accuracy and results, the thing that we are really helping our users through weights and biases is making sure that those experiments and runs are easy, and it's easy to compare the results. One of the things that, maybe not just about eval that I'm really excited relates to agents. When we talk about agents, actually building them, the pipeline, just experimenting is really hard. And we made an acquisition of OpenPipe just last week, which is actually, again, an open source technology that automates this entire process and gives users the ability. It actually automates two things, right? The entire pipeline of building those agents, but also how do I know the result is good, right? I need to give feedback to my agent, like, hey, this is good, this is not good. How do I give that feedback? And actually creating those functions is hard, like that scoring function. So having that like generic one that has great results is something that we are investing in.
Okay, great. Aparna, what do you see as something that's working for building good eval?
I think good evals requires good data. In an enterprise context, that could be your internal knowledge of how a process should work. You have to then capture it in a way that you can actually use it for evals. I've seen a lot of manual tools, Excel spreadsheets that like capture questions and answers and all these corner cases, etc. That's not really that just happens to be where I think most people are. At Vercel, because we have 10 plus years of TypeScript and JavaScript development, we have all this code, which is sort of best practice code, and that serves as data that can be used for evals, and that's why we do evals using this highly curated code base. That's obviously for that particular purpose. But I think each enterprise, each use case has to have their own data to do good evals. Maybe Datadog can help with this. We're a Datadog customer. We have a lot of data in Datadog, and Datadog is our customer. But yeah, depending on, one comment I'll make is I think observability also is changing, right, because of AI. Because I think the user expectation is that you will actually analyze that data and you will give me solutions. You'll give me recommendations and solutions.
Yeah, I definitely think that's what we at Datadog deeply believe in. I think, you two missed this morning's keynote, but we did talk about the real-time, high-quality data that we have. That allow us to not only train better foundation models, specialize in observability, but also use those better real-time contexts in the case of actual inference and solving the problem better for our customers. So definitely we believe in the data being a key driver for the quality of any AI product. So we've covered quite a few topics. Maybe switching gear to coming back to the importance of open source and community contribution in this ever-changing AI landscape. You two both played a key role in open source through the Kubernetes days, but also now again involved in open source in different capacity. How do you see that open source continue to evolve, and also not just in tools and capability, but also open source models that we all get to benefit from in doing AI development?
I think that the reason why we see so much open source technologies and tools is that it's actually makes it the simplest for everyone to collaborate. Okay, and for example, we invest a lot in weights and biases. Like we have a very rich free tier. And the reason why we do that is because we want people everywhere with their different perspective and different use cases to be able to experiment and collaborate and contribute back. So as long as this space continues to evolve so quickly, I really think it's important for us to do that. The second thing that I think it's actually something we can take from what happened in the world of Kubernetes, and I think what helped it to be so successful is evolving some open standards in this space. I know it's not easy, right? If you think about it, like, hey, I want to differentiate with everything, but the more fragmented the ecosystem will be, it will be harder for us to innovate and to build tools and just to move forward and advance this space. So that's an area that we continue to invest. Some recent news, so the Linux Foundation, for example, created a new foundation called Data and AI. I think they've announced about it last month, and really having more AI-centric projects as part of it. And that's something that within CoWeave we support projects by other teams. We've also partnered with IBM and Red Hat on LLMD that takes the assets of VLLM and just makes it more suitable for distributed inference, as an example.
Okay.
I mean, at Vercel, I think open source is really at the heart and the core of what we do. And I would say that was one of the things that drew me to Vercel. And Hen has said, before I joined Vercel, I asked Hen, should I join Vercel? And she said, it's a really good match, given your background and what the company is doing, because of also what we did with Kubernetes. And I think at Google, some of the things that we got right, one is that, Kubernetes came from a system that at Google we had been using for a long time, which is Borg, right? It was a full sort of reimagining of Borg for the rest of the world. Similarly, I think at Vercel, on a much more compressed time scale, we've gone from running something like V0, which is an agentic application that is running at hyperscale, and we've taken pieces of that and we've open sourced it. And that's where the AI SDK comes from. We recently open sourced a vibe coding platform, so your daughter can build her own vibe coding tool. Not just use it, but she can build her own vibe coding tool. So I think that there's a learning there, which is that when something works really nice at scale inside a company, that's the best thing to open source. Like, that's the best. Otherwise, something that's a toy, is not as useful. But when you take something that is actually working in production and you take that and you open source it, it then can actually create a really rich ecosystem and a rich community. And that ecosystem can then develop on that project, and so many new areas come out of that. And certainly that happened with Kubernetes, but we are seeing it happen with the AI SDK too, because there's a whole ecosystem that's developing around it. So you can build chatbots, you can build agents, you can do memory, you can have many different parts of that and sort of specialize in that. And then the other thing that we took from the Google playbook is that, you build the cloud. You build the cloud that is the best place to host the open source. And that's what Vercel is for the AI SDK and agents and so on. We're trying to create that cloud. Of course, it's not exclusive. It wasn't exclusive for us, but we built a really good, healthy business and also an exceptional ecosystem that caused so much, I think, value creation.
You also touched about these open source models. Mm-hmm. I think similar outcomes we see from just any ecosystem, right? When we see those open source models with companies like, for example, Meta, not only they open source the models, they also write a paper. How did they train them? What kind of technologies? DeepSeek, for example, right? So all of those things that are happening are really advancing model development, which I think is really exciting. The second thing is by having those smaller models, make it again more accessible for different type of use cases. Mm-hmm. And for more people, right? Do I really need, how much infrastructure do I need? Can I use less? Can I host my model on a single node? All of those things I love, and it's really happening outside with the academia and the open source community, just sharing those best practices. And it's been amazing. I think maybe something also that we've seen in the past, there's a lot of noise. Aparna said at the beginning, every day there is a new model. Mm-hmm. So something that we are working on, and I know it's something that the community is also thinking about, how do we compare? How do we compare infrastructure? How do we compare models? How quickly can we do that? So I think that's something that it's not yet a solved problem. I mean, there are some tools, but we're just talking about this morning. It's for most people, if you don't know the details, it's like you're actually comparing oranges to apples, mm-hmm. and it's hard. So making that simpler, I think.
One note I'll make on evals, evals can only go so far. We've been talking about this internally. Is ultimately, so you do evals, but the test is really after the evals. The test is really in production when you put the application in production, and to be able to do, A/B testing and to be able to do experimentation, and that's actually getting quite sophisticated, and that's another piece of actually the AI cloud, is being able to run experiments quickly and at scale and choose the best.
Yeah, and those are all great things. We actually talk about this morning. We talk about Datadog's approach to word LLM evaluation, as well as our new foray into feature flagging, experimentation, mm-hmm. and things like that. So maybe as the clock is ticking, one last question as we think about the changing developer-operator boundaries, or the changing software development lifecycle. How is that changing in your respective company, especially, we have a lot of developer, builder, and operators and platform engineering in this room. How do you see, the different teams' roles starting to shift and what they may look like in an AI future? I personally was very excited just even this morning we talk about a developer can leverage MCP to get a whole context from Datadog. That used to be, the Datadog user's specialty. And on the other hand, an SRE may be able to leverage our dev agent to directly impact upstream code change and land code changes. So, people's roles are starting to shift quite a bit with AI and with potentially a new way of thinking about the software development lifecycle. So how do you see that change in your respective organization?
So internally, the approach we're taking is leading with experimentation. Like we're really making a lot of tools and technologies and a lot of models available to our teams, and just letting see like what will come up. Because I think one of the things I love about like vibe coding and is that you can actually describe the things that you need. Mm-hmm. Not everything has to be a standard, or like you can personalize a little bit the experience for my role and your role, and maybe it will be a little bit different, and maybe it will be a little bit different from different companies, and it's really powerful. So we're doing that. We're definitely also making sure that we have the data available, so connecting all the sources. Mm-hmm. And at the end of the day, my hope is that, again, what we are seeing is that we are helping everybody to be more effective and just improving our own, like as a team, an entire team velocity.
Okay.
Mm-hmm. Yeah, I mean, there's definitely a change in the developer workflow. We talked about it. I think the SDLC looks very different now. Anybody can use an agent. So internally, we use many different agents. One of the agents we use is Devin, and basically it's in a Slack channel, and anybody can tell Devin what to do, and Devin does it, right? He doesn't check, like, are you an SRE? Are you a developer? But the one dynamic that I think is particularly interesting and has been kind of difficult to move is the dynamic between security and the developer organization, because there's always been this, like, developers want to move fast, security wants to make sure everything is stable and not moving fast. But what I've noticed is with AI, security is kind of a lot more in the line of fire, because a lot of the threats are extremely business impacting, and also it's not quite clear that they're security threats. They are kind of security threats, but they're basically like AI that is coming to your site and maybe doesn't look like AI. It looks like regular traffic. It looks like human traffic. And it is consuming resources. It's using your infrastructure, and it's maybe even taking your secret sauce and sort of depriving your business. Right? Like maybe no one will come to your website anymore because they're scraping your content and is going elsewhere. And that is kind of a security issue, mm-hmm. because it's a set of security tooling that would prevent that from happening. Mm-hmm. So security, as I see it, in most companies is having to be much more AI aware, AI forward, even at banks, like you have to be very careful about like, what kind of data you allow in, what kind of data you allow out, because that could be your secret sauce, your differentiator. It could be really heavily business impacting, and these things are happening much faster than I think traditional security policies are able to keep up. So I think that's a area that is coming closer to developers and is going to have more of a faster pace.
Yeah, totally agree. That's definitely one thing we're also heavily investing in terms of providing that end-to-end AI security. So we touch upon a wide range set of topics, from infrastructure to developers and observabilities and security, and the ever-changing landscape of AI and how that impacting how we build products. I want to use the opportunity to thank all of you for staying with us for this session, and a partner at hand for sharing your thoughts.
Awesome. Thank you so much for having us.
Thank you.
Hello, hello. Come on up so that we can actually have a conversation. Raise your hand if you use data. Anybody awake? No? Nobody uses data? Okay, cool. A couple of you use data. We do have a lot of good front row seats. You can stay where you want if you need to, but there's a lot of space up here. I am really, really happy to welcome Julian Ledem to the stage to talk about open telemetry and data lineage and open lineage. Thanks, Julian.
Hello, everyone. I'm Julian, so I'm principal engineer at Datadog. Today, I'm going to talk about data observability and open lineage. So imagine we're working at Canoe. So any similarities with an existing company is purely a coincidence. And the key feature of Canoe is recommendation. Not only can you search for a great vacation, it's going to recommend to you a great vacation in somewhere sunny and nice. However, today, for some reason, the recommendations are wrong. Like instead of having the nice, dreamy destination for your vacation, you end up with some crumbly location that you're kind of worried like bats are going to come out of. And to be clear, also, no animals have been hurt in the making of this presentation. So recommendation is wrong. And as any data ecosystem in any company, at Canoe, the data ecosystem can be a bit complicated. There are lots of teams producing and consuming data. And they're very aware of what's happening in their own little bubble, of how they consume data, what their best practices are, and so on. However, sometimes it's a bit hard to know where the data is coming from, right? You're reading from this table or from those files somewhere in blob storage, and you're not quite sure who updates them, how often they're updated, where they're coming from, and it's kind of a bit opaque. And what happens if something's broken somewhere, since everything's automated, like the brokenness and the wrong data like propagates through everything. And if you get the wrong data in, you probably produce the wrong thing out, and suddenly everything's broken, right? Maybe you didn't touch anything to your recommendation job, but for some reason today it's producing the wrong results. And the conclusion is you get from the great recommendation that everybody loves and bring the users back to your website to the thing that's wrong, and everybody says, like, what is this? Why am I even here? Let's get back to something else. I don't want to be in the bats. And so, like, the first thing you do, how do we investigate this? But so everything's opaque, right? I'm not quite sure where it's coming from. This isn't like our system works. I don't know where it's coming from. Someone else, something is broken. I don't know where. It's hard to investigate. And usually, you end up in a situation when everything goes right, everything works, but as soon as something is wrong, it's going to take weeks to figure out the root cause of the problem. And you don't have that luxury. You don't have the time. And what doesn't help is the whole ecosystem is very fragmented, right? Like every team might be using different tools, right? Like there are tools that's more specialized for analytics, for ETL, for machine learning, and a bunch of different things. And depending on the case, you're using a different tool. And when it comes to troubleshooting, they all speak a different language for understanding what's happening, right? Like whoever has been frustrated at not having the right connector, right? Like all of those things, they mostly send the same current, but they all do this through a different standard. And so what we do need is a common language to represent how data is transferred, to understand lineage between different data transformation, where data is coming from, where it's going, how it changes, who owns it, at what frequency, and so on. And as we know, finding a new standard for everything is difficult. Right? Like this famous XKCD, what? We have 14 standards. It's easy enough. I'm just going to think hard about it and find the one standard that encompasses everything. And what happens, soon we have 15 competing standards. Because the thing with a standard, it's not about finding the spec that's going to work for everyone, right? Like if you think of these power outlets, they all work, right? It's not that we need a design that does all the features they all have. They all have the same feature. However, they do it all in a slightly different way. And the way you avoid this, it starts with people, right? To get a standard, you need to start talking to people and agree that we're going to get together and do it the same way, right? It's not like someone is thinking only a subset of the problem. It's just like we're all thinking about it in slightly different way. So you start with people, and all you need to do is a few trailblazers we can help start figuring out how we standardize lineage. And I liked using this image about the stone soup. So if you know this children's story about the stone soup, the story is there's some person that comes to a town square, and they start setting up, they start a fire, they put a pot on top of it, they fill it with water, and they start heating the water, right, and stirring the pot. And when people come to that person and say, what are you doing? Well, I'm making a stone soup. And the image of the stone at the bottom of the pot is just that the stone has no flavor, right? So it's a soup at nothing. However, this person can say, hey, I'm making a stone soup, but you're welcome to contribute any ingredient to it that you like. And maybe someone comes with carrots and someone else comes with leek, and we all put it in it, and we're all making it better for everyone, and we're all going to share. And so building a standard like this, it's often just that, right? You're just creating the opportunity for people to collaborate and build something together, and all I'm doing is really just stirring the pot and making it possible. And there's really a network effect on aligning incentives, right? Like if you can explain how we all benefit from the standard, right? You're not going to contribute to my standard, right? We're just going to build this together. And the more people use it and contribute to it, the more it becomes valuable for everyone, right? So that really creates a snowball effect where the more you build momentum around the standard and the project, the more there's an incentive for other people to join, right? Because every time there's more things in that ecosystem, the more it becomes valuable, because the standard is only valuable if it's been adopted by enough people. So there's really this accrual of momentum that happens. So now I'm going to talk about open lineage, because the thing I've been hinting at is the creation of open lineage a few years ago that led to the standardization now of how we collect lineage for this whole ecosystem. So traditionally, we had 3 different ways to observe lineage, right? And the first way is by doing more static analysis, right? You can look at your code repository, analyze the source code, and understand, maybe you're parsing the SQL queries. Maybe you're looking at your data frame transformation, and you can understand how the output data is derived from the input data, where you could understand at the column level how it's derived from the input. And the downside of this approach usually is you don't know what's actually deployed in production, and you may not know actually what databases it's connecting to, right? So there's some of the metadata that's missing. You have some nice information of how the data is transformed. You don't really have the information on how to connect it to physical data sets. So it kind of has some holes in it. Another approach has been using existing query logs, right? If you have a data warehouse, and that's the main way people query, consume, create derived data sets using create table as or things like that. You can look at the query log and you know everything that has been happening, right? And traditional way of doing this, you can parse all the SQL queries and you understand how each table is derived from another. Downside of this approach is you lose a lot of information because it's after the fact. It's not necessarily being collected, understanding where the queries are coming from. You may not connect is this an ad hoc query? Is this something that's recurring every hour or every day? Is it part of an ETL? Is it part of some transformation to model data? There's a lot of information that's being lost in the process. So you have a fairly accurate view of everything that happens in the warehouse, not too much what happens upstream of it, downstream from it, or in other environments. And so it also has some gaps. The third way to do this is to observe the pipelines as they're running. And, spoiler alert, that's kind of the open lineage approach, right? We integrate with the data orchestration systems, and as the job runs, right, you can instrument the job and observe what's currently happening and get a lot of metadata that's related to what's happening at the moment. And because the job is running, that's where all the metadata information about this particular job is available. And so if you can collect it, you can then centralize the collection of it and infer lineage. So to give a little example, right, if you look at the picture you took, you can look for the metadata after the fact, right? If it's a picture of the sunset, you can infer, oh, look, it's a sunset, it was taken about at this time, it's facing west, there's like probably this location. There's something you can infer after the fact, but it's never going to be as accurate as the information that the camera, if you instrument it, can collect, right? Like modern digital cameras, we capture longitude, latitude, time it's taken, metadata about what lens you used, and things like that. And it's going to be way more accurate than using something that's not designed for extracting metadata and that has been saved and use it after the fact. So instrumentation is really important aspect. And so you could say that OpenLineage is the EXIF data for data. So if I look at OpenLineage, it's made of 3 things. One, it's a spec. It's an open spec that explains how you describe lineage and related metadata, like it could be data quality metrics. It could be schema, it could be a lot of other metadata around this data. It could be query profiles. Second, it's libraries to make it easy to integrate in various different languages. And last, there's a list of integration with the most popular open source data frameworks. And so before, the way lineage consumption would happen, you would have a lot of lineage consumers, like maybe data catalog, maybe they worry about compliance, maybe they worry about data reliability. And you have this common quadratic problem of all the consumers need to talk to all the producers. And there's lots of reverse engineering happening, right? All the various producers have some notion of lineage, but it's usually all very specific. Sometimes it's not even public API, so there's lots of reverse engineering looking into the internal of the systems to extract the information and see what's happening. So that creates a lot of complexity and a lot of brittleness, because it's all relying on internals. Whenever something changes, it can break the integration. So this just creates a lot of work to keep creating and maintaining the integration with that. So if we can define a standard, like we get rid of the quadratic complexity, and we can get to a much simpler situation that it's more linear growth with the ecosystem of how much work it is. Because each new producer of lineage, whether could be Spark or Airflow or dbt or any other things that transforms data, can just comply with producing their lineage metadata in a standard way, and all the consumers can just consume in that standard format. It makes it a lot easier. Since now we have an explicit contract, it's a lot more stable. People don't break the lineage definition willingly, and it's a lot easier to scale the whole ecosystem. So that's where the more people use it, the more people benefit, because any new producer that uses it, all the consumers benefit. Any new consumer that uses it, you get visibility in all the producers. So there's really like this snowball effect that builds from that. So being in observability conference, right? Like I'm assuming a lot of you are familiar with OpenTelemetry. I'm going to talk a little bit about the parallel between OpenLineage and OpenTelemetry. So if you think, like, OpenTelemetry is a project led in a CNCF, which is a sub-foundation of the Linux Foundation. It's a collection of tools, APIs, and SDK, right? And it lives in that ecosystem. So if you think of OpenLineage, it is the same thing, right? So OpenLineage is part of the LFAI and Data Foundation, which is a sister foundation of the CNCF. It's part of the Linux Foundation family of foundations. And it is also providing the same functionality, but for lineage, for data pipelines, instead of telemetry for services. And if you think about it, there's a lot of similarity between lineage and traces. However, they work slightly differently, right? So there are lots of concepts that are similar, but because data pipelines work in a different way than services and traces, we do have to define a different standard on how to represent things. If you think about it, right, when we think about traces and services calling other services, you always have a tree of dependencies, right? The request come on first service, and you see those spans are contained within the main span, right? Like first service is called, we're going to call another service, the service B, and then service B called the service C. When C returns, B calls the next service D, and then when it returns, it goes back to A that can call the next service, right? So we follow this tree with the depths first and going through this. The first service is aware of its downstream dependencies because it's calling them synchronously. Now, if we think of lineage, it's slightly different, right? When a job produces a data set, it is not aware of the downstream consumers. You always have an indirection between jobs and data sets, right? A job writes to a data set and another job reads from it. It reads from it, and it also doesn't necessarily read from it at the same granularity, right? You could have an hourly jobs or daily jobs. They may not be in sync. And there's always this indirection between the two. So the job A finishes, and then job B and E will happen later on, and the job A is not even aware of it, right? So you have, it's not a tree anymore, right? It's different type of interaction, and that is why the lineage model is different, right? Because we capture metadata in a very different way, where there's not correlation ID that propagates down the call stack. There's no call stack in this case. But when we think about it, it's useful to draw the parallels because they are very similar contract concepts that we can use. So on the services, you will have service APIs as contract. On the data, it's the dataset schemas. When you look at distributed traces for services, it's similar to data lineage and how we connect dependencies between the various transformations. And in services, SLOs are thought about as availability, latency. In data, it's freshness and data quality. Freshness is, has my data set been updated in time compared to the last time the upstreams was modified? And data quality is the actual data correct, or do I have errors in my data? And so going down in more details on how Open Lineage works, it starts with a simple model of 3 core concepts. You have the job. The job is this thing that is recurring, right? A job will run multiple times a day, but the run is each instance of the job running. So you will have a job that has a unique identifier that identifies the recurring job, right? That might be running every hour. And it reads and writes to data sets. Data sets are also identified with a unique identifier, right? The key, one of the key elements of the Open Lineage spec is standardizing how we identify data sets across data transformation framework in a way that we can reconnect and stitch the lineage back together. And so on each of those entities, you can attach facets. Each facet is a atomic element piece of metadata that's defined by a JSON schema that attached to one of these entities. So to give you examples, a data set might have a facet about the schema of the data set, right? It could be, if it's a table, it could have a schema. If it's a Kafka topic, it might have a different types of facets attached to it. On a run, you might have the query profile attached as a facet, and so you can understand better performance or cost of various runs of a job. On the job, you may have the query plan or some information that may vary depending if it's a Flink job or a SQL query or a Spark job. And all of this is connected in a run event. The run event is the thing that ties all things together, right? If you think of the life cycle of the job, we'll start with a start event when the job starts. So if you think of a batch process, you will have a start event that gives metadata about the job. Where is it reading from? Where is it writing to? And then the main other events there will be is the complete event when the job is complete, and that we know it's finished running and when it's finished running. If it's a streaming job, you will have the same thing, but since you don't really know when it's going to complete, you often have running events in the middle that show progress of the jobs. For example, in the Flink integration, we're going to send a running event every time there's a checkpoint. And if you're worried about having too many events, you can also cap the number of running events. Sometimes people checkpoint very often, and therefore they may not be interested in having an event every time this happens. And of course, if the job fails or is aborted, you get a different event than the complete event. And to give you a quick example of what that looks like, OpenLineage is defined as JSON event. We have JSON schema for the core spec as well for each of the single facets. So if we zoom in, the first section here is the definition of a run. And you'll see in particular, we have the parent run of what triggered this particular run. So if you think of, for example, an Airflow job having a task that starts a Spark job, you will have the Spark job will connect up to the run that triggered it in Airflow, right? So that's how we connect nested jobs, like you may have an Airflow run that runs a Spark run, and they're connected together in the metadata. At the job level, you may have some facet. For example, if you have a comment description of the jobs in your Airflow task built in your code, this can carry over as a facet. So in your observability side of things, you know what this thing is. You will have inputs. The input data sets here shows, for example, the schema at the time of reading, so that from one run to the next, you can see whether the schema has changed, and that may have caused a problem you see in your job. In the output here, we're collecting metadata about the output. In this case, we're capturing output statistics. For example, when you run a Spark job, Spark collects statistics on how many rows were written to this table, and you can keep track of this. So for each run, you know, you can have like simple statistics on how many rows were written by this particular run, and that can be an indicator later for troubleshooting things. And since we standardized how data sets are identified, you can stitch lineage together and understand the data flow end to end. And so to finish, I'm going to go a little bit more in how that looks like, how Datadog leverages OpenLineage to improve its product and makes your life easier in troubleshooting things. So if we get back to remember how suddenly our website got haunted by bad data and bad recommendations. So how do we get there? How do we fix it? So everything was broken. Something was broken somewhere. And since we don't know what happens, propagated everywhere, we don't know how to troubleshoot. Now, if we have lineage, what we can do is walk backwards this graph of dependencies. Now we can understand it better and see where the problems is coming from. Right? So, oh, wait a minute. Now I'm not like, well, I didn't touch anything. I don't know where the data is coming from. I don't know what's broken. I can actually just go in the tool and walk back and find, oh, wait a minute. This has changed. This has changed. This is not like before. We can actually find the team is like, instead of being, I don't know, ask this other team, we can go see the team and say, oh, hey, I noticed this. This looks funny. Can we work together on solving this, right? And now, because you see what's happening, everything is easier to resolve, and there's a little bit less of throwing the rock over the wall. And, you know, I don't know. You know, because you can start, so this is the job view, and you can say, hey, this is my recommendation job. Look, it's been running the way it's always been running. Everything looks fine. Everything's green. This is fishy. What's happening? Let's look upstream, right? So I can go to the lineage page and see, oh, wait a minute. So I'm depending from this table, and I can keep going upstream and see what happened. I can mouse over things. It's like something as an alert. I can start looking at the data quality metrics, like are we having fewer rows than before? Are there more errors than usual in this data quality check and so on? And then I can go deeper, right? This is an example of having an Airflow job launching a Spark job or multiple Spark jobs, right? So the green lines, the green spans in this graph are the Airflow jobs, and all the colored ones are individual Spark jobs that have been triggered by it. And because things are connected across those frameworks, I can actually see, oh, look, this Airflow job triggers a Spark job. If there's any problem that's related to things being slower than usual, I can investigate more, right? I can look the historical runs and understand why this thing is slower than it used to be. Because we connect traces and lineage, right? We have the trace instrumentation in Spark, and we have the lineage instrumentation in Spark and in Airflow. We can actually look at what's happening across those frameworks and understand better where things are happening. This is especially useful if something is suddenly much slower. You can dig deeply into, oh, what? Wait a minute. Now I understand what the time is spent, and I can see the frame graph across everything. And by the way, that works as well for a dbt model. You can get the same view because they're all integrated in the same way, and you have this abstraction of jobs and dataset and lineage. You can actually understand, dig deep and understand what things are happening. And so now, well, wait a minute, we got back to our website being fixed. And we were able to do this, having constructive conversation between different teams and not like, throwing our arms in the air and say, like, I don't know, it's so hard to troubleshoot everything. And actually, there are lots of possibilities, right? Like, we've been talking about the data reliability and troubleshooting use case. But one thing you can do is, since you understand your dependencies, maybe you can prevent problems to happen in the first place, right? Of course, you can use lineage to walk upstream and figure out what caused the problem, but you can use it to look at the other way and do an impact analysis, right? Like before you push something to production or like you push your change, you can actually check who you possibly are going to impact, and maybe if you communicate about pushing your change, instead of sending an email to the whole company that nobody's going to read, you can contact directly the teams that are going to be impacted. Hey, watch out, we're doing this change tomorrow. You might want to look out for what happens, right? Or I can just know that it's not going to break anything. Also, a bunch of use cases for regulations. If you want to be compliant, there's tons of reasons why you would need to know lineage, or just knowing where your user private data is going, and it's going only in the places that it's supposed to be going, and avoid having fines because you don't watch out where your user private data is going. So how does this benefit you, right? You get clear, unified, cross-platform lineage. It's easier to debug and trust the accuracy of your data. And an open standard ensures it's going to work consistently everywhere, right? Like it's only going to keep growing and have more visibility into it. And concretely, if you're interested in investigating in this, I would recommend first identify your key data sets and jobs, and start from there and look upstream, right? Sometimes getting lineage feels like boiling the ocean. Start with the things you care about, right? You don't need 100% lineage. You need 100% lineage on the things you care about, right? So focus on those first. And there's tons of instrumentation in open lineage, whether it's Airflow, Spark, dbt, Flink, also proprietary ones. It's also been adopted by the 3 main cloud providers. And thanks to combining traces and lineage, you can achieve a lot. Thank you. If you want more information, you have all the contact information for the Open Lineage project. And you can get the main way of communication is often the Slack. You'll find an invite link on the website. And if you want to learn more about the data observability features at Datadog, this is the documentation. Just Google Datadog data observability. And on that, I can take a few questions.
Thank you very much. You can now send the event complete to the run. We have some mics in either aisle, so if you have questions, please come up to a microphone. You've got Julian's undivided attention. I don't see any people just yet, but I know that they will get there. There's a microphone right there. Yeah.
Yeah, and I can't see you with the lights, so just speak up.
We really can't see anything. Oh, no. All right, somebody's going to the mic, maybe?
Or that, or they're trying to... No,
yeah, go ahead. You've got a race condition.
So I had a question on the open lineage and the integrations for it. Is it purely limited to ETL tooling, or if we wanted to integrate it within whatever like services generated the data, like the backend services, cloud functions, etc., would it be able to integrate into those components as well?
Yeah, it's going to integrate with whatever emits open lineage. So sometimes people even build their own custom open lineage event. So since it's JSON, you know, if you have like, because if you're using Spark or Airflow or dbt, all those things have built-in integrations, right? If you build your own thing, you can create your own open lineage events. Sometimes people, they write their own open lineage events for a custom job that's just a process you've written in some language and you're reading files or writing to tables directly and there's no integration for it. You can do it, or anything that has an integration, right? It's really open to anything that transforms data, really.
And are there like open source libraries to run those integrations, or is it just like a standard that we'd have to follow?
So you can either directly generate JSON, and you send JSON by sending a post over HTTP, for example, or there are also libraries in the most common languages, Java, Python, Go, to produce events as well.
Thank you.
You're welcome.
I was wondering if the standard addresses consumption of data from the front end and all the way through microservices to the actual final data sources.
So there's still, so that's one potentiality, right? So if you have, let's say you use a RUM from Datadog, and then you're using APM, and you have traces, and then you have lineage, eventually we'll connect everything. So we're not, I think the product doesn't quite have everything connected, but one day it will have connect everything, but you can start seeing what's happening on the service side, right? And then maybe from there you write to Kafka, and then from there you dump this into buckets, or you put it into your warehouse in a table. And then from there you have dbt jobs transforming the data. So I don't think we have quite features yet that connects everything. We do have all the data, and you have views for the service side of things, and you have views for the data observability side of things. And one day we'll have like connected everything together so you can follow the flow. But that's definitely in the works.
If you want to learn more about data pipelines and tracking them, stick around for the next talk right here.
Oh yeah, the next talk is going to talk a lot about data quality and all the related problems.
One more?
Yeah, one more. Just, is there any collaboration with OTel around ingesting and transporting the open lineage events into a storage system?
There's been like several conversations in the community. I had given a talk a while ago at a meetup, like talking about open telemetry and open lineage, and there's been discussion in the community on how to connect both together like better. Because the data world is often like pool-based, right? It takes the data from the data set and writes, and when the service world is more push-based, you have to reconnect, and how we connect the dots and making them work together. So there's still work in progress, but it's definitely something like we're looking more. And because we get all the data in one place, we are definitely incentivized to make the connection work better. And I see Jonathan over there. If you have questions, this guy with the cap, you can ask him more questions about what the product will do.
Thank you so much, Julian.
Thank you.
Good talk.
Hello, welcome. Please feel free to move on up if you would like. We got loads of seats. I actually checked. We have all of the seats available, not just the ones in the center back. But you can stay where you are if you would like to. Please join me in welcoming Marian and Jonathan to the stage to talk to you about data observability and data pipeline.
Hello, everyone. So today we're going to talk about pattern and deviations in data pipeline. And specifically, we're going to take the vitals of the analytics stack. So let's start with really a nightmare, a bad dream. So picture this. You just open your computer, you get to Slack, and there's a message on the main analytics Slack channel that is telling you that dashboards are empty. And it's a silent failure situation, so Airflow didn't fail, dbt didn't fail. There's no obvious explanation. And it's really a freak-out moment here, because stakeholders are the ones who told you, and you didn't know. And the cause behind the empty dashboard in this real-life scenario was a slowly changing dimension table, which in the data warehouse preserves the complete history of a record, went wrong. And in that case, a new field was updated in production without updating the updated at timestamp. And this basically invalidated most of our records. And that is what our table looked like. All of our users in our users dimension were invalidated, and therefore the dashboard that tracks the number of users by organization looked like everybody was inactive and was effectively empty. And it was, as I said, silent, nothing failed, and it was especially painful since back then it was a pretty simple stack. We only had Airflow ingesting data into our data lake, and it was really a couple of databases. We had dbt transforming the data into the data warehouse, so effectively building the foundation of our data model. And we had a few Looker dashboards out, and obviously more eyes on the data. But when this silent failure happened and stakeholders knew before I did, I was reminded of what I had seen at a previous company, which was how too many failures too often without you, analytics person, knowing about it beforehand, just erodes trust in the data warehouse. And also the reality is you can't catch everything all the time. And with that said, I'm Marian. I'm a data and analytics engineer at Mux, and my job is to ingest data from multiple data sources, working directly with the engineering team to do so. So I ingest data into Snowflake, transform it using dbt, and I make data available and accessible to stakeholder. We've talked about how important data quality is, data freshness. I try to make sure that people can trust the data at Mux.
And hey folks, I'm Jonathan. I'm on the team here at Datadog. I do also like data and dogs and cycling. But I'm part of the team at Datadog that helps folks like Marian help data teams basically improve the trust in their data. Also part of that team is a company Datadog acquired called Metaplane, focused on solving that problem. Datadog traditionally observing applications, and now in data observability, observing the data. Marian's going to walk through what that looks like at Mux, and towards the end of the presentation, I'll show a little bit about how that's coming together in the Datadog platform.
And just briefly, what is Mux? Mux is a video infrastructure for developer company. I haven't tried, but I've heard that streaming video is really hard. And Mux solves a lot of those hard problems for you, effectively abstracting everything behind an API. So if you think about billing and Stripe, think about Mux and video, so solving the hard problems for you. And what it means for me as an analytics person is video is a lot of data. And going back to my empty dashboards that I was talking about earlier, everything is still broken. I didn't know about it, and it's still an issue. And let's take a step back first and try to figure out how did we get here. And really, especially today with AI in 2025, assembling a data stack is incredibly easy. The hard part comes later. You can ingest from various data sources, with an example here using Fivetran. Only in a few clicks, I checked on their website, and they have 700 different data sources. So you can ingest this data easily into your data lake, transform it using dbt, which ensures a nice DAG, column-level lineage, transform this into your warehouse, make it available to your stakeholders. For instance, you could ingest your NetSuite data, which is your accounting data, using Fivetran in a few clicks. Use a dbt package to transform this data. You don't own the logic. You're just using this aggregation logic from the package, and then build a few reports on top of that. And that's it. You're done. It's only a few clicks. And over time, obviously, you add more data sources that you ingest into your data lake. You may have multiple people contributing to your dbt repository. You may have several people building Looker or Hex dashboards, and you may even be sending your data back to systems like Salesforce using a third-party integration like HighTouch, which, again, only a few clicks. And really, whether it's raw or aggregated, it's really easy to put data out there, raw, aggregated, give them to stakeholders. And as time goes by, it just gets to be more and more.
On paper, it looked so simple, but then as it manifests, it just quickly gets quite complex. So who all here is looking at the screen or looking at these data stack technologies and thinking about your data pipelines? If you're not already, maybe you are now. Now, keep those hands up if you could go to a whiteboard and draw every component of that data pipeline. I'm seeing some hands go down. It's challenging, right? Well, you're not alone, and this is exactly the challenge. So, how do we figure this out, Marion?
And to illustrate this, really, what the problem is here is that data is a product, and whether stakeholders are querying the raw data or aggregated data, if you build it, you need to maintain it, because people will use it, and there will be a spreadsheet somewhere pulling data from that table that you need to maintain. And why is it tough is because you have a lot of customers. The analogy here is a kitchen, and we're making sushi, grabbing our raw products, transforming it, and serving it to our customers, making sure nobody gets sick. And where it's tricky for you is it's a lot of tables to maintain. Raw data can go stale. The format can change. One wrong source can corrupt multiple tables. And usually, people will not tell you that something's wrong. A very kind software engineer might ping you that they're having an incident and it's going to impact the data, but more often than not, nobody's going to tell you. And it's especially tricky because you're the analytics team, notoriously understaffed, and there are lots of people looking at the data. And between you and the person who lives and breathes in Salesforce, you don't know what the data should look like, but they do, and they will expect that new value in that new dropdown to be reflected in the report. And similarly, people who look at a dashboard every week will expect a trend. They will know what the data should look like. Is it like your usual 15% increase? Yeah, I don't know, but I know that some people do. And I know that I don't have all that context, but the stakeholders do. And as I said earlier, people will build things on your data. And data can have a rich life after it's generated. From a spreadsheet to sending the data back to Salesforce, it may not be the table itself. It's going to be an automation. And these days, it's going to be an AI workflow that's leveraging your data. So, and this ties back to the previous presentation. I don't have open lineage. Like, I'm not aware of everything that people have built on top of my data. So I'm trying to keep it up to date. Sometimes I can't. So I, however, don't want people to lose trust in the data warehouse. So I tell them beforehand, because internal stakeholders are your customers and you want them to use your product. It happens, incidents happen, and it's okay as long as you can get ahead and tell people to ignore specific tables or just focus on data up to a certain date until you can fix it. It honestly doesn't matter that it's an upstream issue. To the VP of finance looking at their dashboards, they don't care what was wrong in the whole pipeline. What matters is that your report is wrong, and that's what they will remember.
Yeah, and I just want to call out just this shift of the data team proactively telling the consumers that there's an issue, I'm looking into it, is often an upgrade in trust, right? Often it's the business users complaining, hey, this data doesn't look right. I mean, who hasn't been in that situation? You're looking at a dashboard, like, something is off about this. Slack, something is wrong with this dashboard. But it's like in the restaurant analogy. If you had to go to the kitchen and say, hey, is the fish okay? And then they said, oh, actually, it's not. I'm probably not eating at that restaurant again. But to see that the data team is on it makes me already feel a little bit more comfortable and increases my trust in the data. That said, easier said than done. So how do we actually achieve it?
And it's hard. And let's first illustrate the complexity and see how complex it can get as you begin ingesting from various data sources. And in here, you've got ClickHouse, you've got some Cockroach, and you've got some third-party applications into my data lake. So yeah, take a guess. Where can it go wrong in here? Everywhere. Really everywhere.
And I like how you put it earlier, catching issues within the data itself is often, it really is a silent failure. Like, we're looking at platforms to see, is Kubernetes up, is the database up, all systems are green, and yet when these nuanced issues happen, it's under the hood, it's these silent failures. Solving that alone is hard enough. Marion's going to show us how she does that. But then once you see an issue in the data, next question is, where did it come from, and how do I solve it? And so calling each of these out is, I think, actually helpful just to face the problem.
And we're going to focus on one little bit of the complexity and ingesting data from one of our ClickHouse production databases. And really, we're zooming in. We're still like thinking about making our sushi. So think about getting, the raw data, your raw produce that gets exported into a bucket, a bouquet for Max, a bucket, and that then gets picked up by Snowpipe into the data lake, transformed by dbt, aggregated into our data warehouse. We had issues scaling Kafka, so the team built a dedicated service that we use internally to export data from ClickHouse, drop it into either S3 or GCS, and have made something like fairly reusable. Now, thinking about that, let's see where it can go wrong, or how it can go wrong, really. And it can be, again, everywhere. It can be an issue with the data in production. It could be that the exporter is wrong, it's unavailable, it doesn't have permission to write to GCS. It could be Snowpipe. The issue could be in the data lake. Something can get stuck somewhere. The format can have changed upstream. Or one of these items on the list is late, and everybody else is late. So it can go wrong in multiple places. And really what we're doing with Metaplane and what I've been doing is just trying to catch issues before my stakeholders do. And that's how I monitor this stack today with Metaplane, using a custom monitor on top of the copy history for Snowpipe. I've got some freshness and row count monitors on top of Snowflake in the data lake and in the data warehouse, and a monitoring of the DBT job for just how long my DBT job takes. And this is really the power of patterns, because I cannot know how many tables are going to be, how many rows are going to be inserted into every table of my database. But if Metaplane tells me 25,000 rows were inserted yesterday, 24,000 rows the day before, and I have 1 million today, then something is off. And similarly, I know that my DBT job takes roughly 2 hours every night. If it takes half that time, something is off. If it takes twice that time, something is off as well. And I was super excited about the Metaplane acquisition by Datadog, because I think it will allow people like me to shift left. And ultimately, when something goes wrong here in my stack and I see a monitor go off, what I want to do is check the bucket and if files were written, and how many files are supposed to be written every day on that bucket, and when was it last updated. And I've been wanting to do this for a very long time, so yeah, thank you.
So what Marion's going to do is we'll step into her kitchen and see how she's catching the issues in the sushi before it goes out. And then after that, we'll look at how we're working to connect exactly these dots and work towards telling that end-to-end story.
So this is what I do every day, obviously. And we're going back here to my ClickHouse exporter. And in that case, in this sad, very sad real-life example, the production database started rejecting queries, not just for the exporter, by the way, for everyone. So like exporter was the second hand here because customers were also impacted. But as a result, no rows were being picked up to be sent to GCS. And as a result, the freshness monitor started to fall behind. And in a very consistent pattern, the row count was also pretty stagnant. This was a production incident for everyone involved. And what was cool about the Metaplane row count monitor is that when we backfilled the data, we were able to see how it was caught up, which without this like quick looking at the trend would have probably needed queries here and there, both in ClickHouse and the data lake. So it was really, really neat and easy and a nice surprise, frankly, to be able to do that. This example is from the custom monitor on top of the Snowpipe copy history. And frankly, that monitor never alerted, and this is me trying to do a manual backfill and messing up the file format. So the file wasn't imported. My monitor alerted us. But yeah, at least I know that it works. And I'm clicking for the next slide. There we go. There's a slide delay. Okay, we're back. Another cool monitor from Metaplane is the source to target monitor. This is not directly monitoring ClickHouse and Snowflake. It's a different set of databases, but the principle is the same. Going back to our sushi, this allows us to see if we moved data from one source to a target database accurately. And this will just do a row count every hour, every 15 minutes, whatever you want, and make sure you moved all your rows. And the last use case that I think is just a nice, like, different use case that Metaplane helped us uncover is like the data version of bugs. So it's when there's an application bug and it translates into data being different or just data is a symptom. In that case, we have a table that collects the CDN logs, and we have a monitor that looks at how many 500 errors we had. And in this case, requests were being made to a video that doesn't exist, which spiked the number of 500 and allowed us to tell the engineering team, like, hey, you know, this is, we usually get a certain amount of 500, but clearly the pattern and this spiking that much shouldn't happen. So it was later, I think, tied to a bug. So really, the takeaway here is to be looking for patterns. What I've learned over time is that Metaplane is usually right. I'm just maybe like not able to explain it always at the time. So it's telling me something's wrong. I'll be like, I don't know, mute it for now. And a week later, I will hear that, you know, somebody was sending a lot of emails and therefore like HubSpot is spiking. So it's always right. I just can't always explain it.
Thanks so much, Marion, for walking us through how you're actually putting that into practice. Now let's take a look at what that end-to-end sushi supply chain might look like, or, of course, data. So let's say I work for, not Mux in this case, but a travel booking site, let's call it Canoe. And, of course, my business relies on travel bookings or referrals to travel bookings. And if something is off about the price I'm quoting, I could be losing money pretty directly. So again, I could be monitoring that my application is up and users are going to my site. Maybe they're even checking out. But if they're checking out the wrong price, that's a pretty critical application and business issue. So first thing I do when I get alerted about this and come into Datadog is I want to ask, is this a real problem? And does it matter? And I can see it matters not only because I have the context that it's pricing data, and my table's labeled pricing, but I can see downstream applications using this, including my vector database, bringing this to my AI experience, as well as internal business dashboards, many of them, because everybody's looking at the pricing data. So I say, okay, indeed, this is something worth solving, but what's happening? And upstream, I already can see a failing Spark job that might have something to do with it. But before I look at upstream, I want to dig closer into the issue, and this goes into the pattern deviations to catch data issues that Marion was talking about. In this case, there's my spike in quoted pricing. In this case, you can tell I've already resolved it. My pricing data point has come back down. That's in the background with my multiple screenshots here. In the foreground, you see how this was configured. In this case, it was a custom SQL specific alert to look at the column I was most interested in. Now, because of course, this is a business-specific check. This is not a check that might be needed for every business. This is specific to a pricing data point for my business. That said, a lot of common data checks like freshness, row count, at the table level, at a column level, that I can also configure here will get you pretty far without necessarily needing to write those custom checks. Let's go back to why that issue might have occurred. In this particular case, I won't take everybody through all the specifics, but what the screenshot is showing is a story where the Spark job was not able to compute the data for the pricing because it wasn't receiving the data in the first place from this S3 bucket, or bouquet, which I guess is our new pronunciation for bucket. I'll let you guess the language. Upstream from that bucket, though, is my application application stream being fed in from Kafka. And so here is Datadog working to show me not only the pipeline that failed, but the application that this pipeline sources from. So I can go talk with the developers about that issue and how I might be able to remediate it. And of course, getting the right teams to even know about these downstream issues from features they shipped in production is part of the breaking down of silos, or at least part of this end-to-end troubleshooting we're trying to enable. And even if you take that, that connection away, developers may be experiencing issues related to data anyway. So going all the way back to those production databases, which I believe were the sushi and rice purveyors and the sushi analogy, here's our production database issue, that production database which is experiencing, not in this case even being flagged about a data quality issue, but something that developers would care about is a slow performance, slow experience, a bad experience for my users in production, also due to a data change. And so this basically shows a little bit what we're doing to try to connect those dots from consumer of data to the data pipelines upstream to where those sources came from. Thanks so much, Marianne, for taking us through what that looks like in Mux. Thanks, everybody, for coming to the talk in the first place, and we'd love to hear any Q&A.
Yeah, please come on up to the microphones. Please give them a round of applause. Do we have the microphones in the aisles? I don't see them. We do. Okay, cool. If you have a question, please come on up. I had a question. So if I want to add all this observability to my data pipelines, does this add a lot of overhead for me, either in terms of performance, cost, data produced, more services I have to actually subscribe to and pay money for, or what's the impact?
There's definitely, there's the tool for sure, but I would say from a monitoring standpoint, I feel like in Snowflake we run everything on top of an extra small warehouse. It's not significant, and at this point the benefits really would outweigh the price. It is not that hard to get started. Just a row count and freshness will be automatic, like even daily or hourly will get you a long way. Like I think as you said, like the need for custom SQL, like sure you can get there, but the basics can get you a long way, I would say.
Yeah, what's nice is, I mean, it depends on the system. So in a case like Snowflake, the query logs are not asynchronous, and spinning up a warehouse is not asynchronous with your production use cases. It's in parallel. Versus at the end, I forget if it was a Postgres or SQL Server, it was a production database. There, we do want to be mindful about the query load we're putting. So what we do right now, I think by default, is we collect schemas a lot less frequently for the schema diffs than we do the regular query performance data. It's every 10 minutes instead of every 10 seconds.
And so at Mux, are you using a lot of these out-of-the-box monitors and alerting, or are you doing a fair amount of customization for your specific stack?
No, we're using mostly out of the box. Like the custom monitors are where we can tap into the copy history, which is not a native monitor. That's a nice feature request. But no, mostly it's like the basics and row count. I'm sure you can get fancy and monitor your KPIs using custom SQL. I haven't gone that far, but you can.
Question, please.
Hi, my company has a lot of very complicated airflow pipelines, and they don't run at a very specific time every day, and not all the same ones run every day, but we really need to know if one of them doesn't run on time. Do you have any advice for how to know if that happens?
Where can you know, like can you at least, like it goes somewhere, right? Can you figure that out by monitoring the database it goes to?
Usually we check like job completion time, so we have that information, yeah.
And can you know, could you monitor how many rows get inserted every day? Could that be helpful? Even if you know that like it doesn't always land at the same time, but Metaplane has some machine learning, so it's like maybe it would be smart enough to know that if a little longer has passed, then more rows are expected.
Okay.
Yeah, so I think there's two approaches here, right? Monitoring the data, the destination data source, destination data that the Airflow DAGs might be writing to. Earlier, there was a talk on Open Lineage, which actually integrates very closely with Airflow as a means for monitoring. So then it's just a question of getting the signal versus the noise. And in that case, I mean, certainly catching job failures with Open Lineage or whatever you're using to monitor Airflow is pretty straightforward. And any tool that is monitoring Airflow, certainly Datadog. If it's only for certain jobs, and only for certain jobs I care about the exact timing, then it's just a matter of, I think, filtering down the logic and in the monitor's configuration.
Thank you.
Any other questions? Go ahead.
Hello. So the company I work for, we're a Datadog customer. We use you heavily for all of our production monitoring, but I think probably very light usage for our data warehousing, transformation, all of that. So I was looking at the charts that Marianne made that just showed all the places that can break down, which is really anywhere in the pipeline. So I'm curious, how would you recommend getting started for somebody who's already an existing Datadog customer? What resources are there for starting to monitor? That's the first part of the question. Like if we want to start monitoring our data pipeline and all the transformation processes. Second part of the question is, how much of that work would be done by Datadog agent versus custom metaplane queries, or are they kind of integrated together now after acquisition?
Yeah, so I'll try to break down the questions I heard and then feel free to add after that. So how to get started? I guess the question that comes to mind to me is figuring out what is the most important starting point for you, and maybe it might be the easiest starting point. There are deep integrations in Datadog. There are also less deep integrations in Datadog. So I think there are now 900 out-of-the-box integrations. So as you look at any tech stack component, most likely you'll see in the 900 integrations, you get a couple metrics. So it's like, okay, is there a basic thing going wrong or not going wrong? Not necessarily full data lineage or data quality monitoring, just a little bit of signal, right, on these systems. So that's one potential way to get started. But it could be, no, what I really care about is finding that freshness issue with this table. Okay, that's where I get started. As for how Metaplane is coming into Datadog, that's still very much in progress and something we're working with design partners on. And what you saw today is how that's looking so far for those column-based and table-based data quality checks, specifically on Snowflake. And we're working in parallel on other top data warehouses. Happy to talk more maybe about your use case. But I don't know, Marian, anything you'd add to that?
I agree. I would start as an analytics person. I would say what are the most critical dashboards, for instance, and start there and go up the chain, up the lineage. But otherwise, if you want to make sure that everything is ensure freshness, that's also an easy way to start. But otherwise, yeah, the most critical data assets is where I would start.
Great. Thank you both for your answers.
Thank you.
Last call on question. Yes, we got a question.
Sorry, a question about compatibility. So for those with pipelines using Apache Pulsar and Flink, is there anything that Streams Monitoring can help with, or are there any plans to add support for it?
I missed the first technology. I heard Flink.
Apache Pulsar.
Okay, I see.
Which is kind of alternative to Kafka.
I'll be honest, I have to actually double check where we are on those integrations.
Okay, thank you.
Thank you.
Congratulations for stumping Jonathan. All right, if there are no further questions, please give Marian and Jonathan a round of applause. Thank you very much.
Hello, everybody. Please feel free to come on forward if you want to get a close look at this next panel. We have 3 amazing speakers to talk to you about RUM and the kind of insights you can get from having a detailed look at user behavior. So please give a very warm welcome to Kevin, Phil, and Viswa. I know names.
Hi, everyone. Thanks, Max. Phil Stevenson here. I'm a solutions engineer. Yeah, the lights are bright. I'm a solutions engineer at Datadog. I am visiting you here from Portland, Oregon. And I'm joined by Viswa and Kevin. Viswa, do you want to introduce yourself?
Sure. Hello, all. My name is Viswa. I am responsible for developer experience in my team, and we support all crucial enterprise-level applications, and we are the SRE team at NVIDIA.
Thanks. Kevin?
My name is Kevin Bigler. I'm a senior software engineer at Cambia Health Solutions out of Portland, Oregon. I'm on the team that's in charge of the healthcare member website, so in charge of both the solution architecture for that, as well as maintenance and support, like on-call support.
Thank you. My first question actually is for Viswa. Given all the success and growth in NVIDIA, especially in the stock price, shouldn't you be retired right now? Okay, just kidding. Let's talk about RUM. So, Viswa, can you just tell us a little bit more about some of the systems at NVIDIA that you build and maintain, and maybe how many users do you support?
Yeah, that's a good question. So, like I said before, we are the developer experience team. We support a lot of enterprise-level applications across the globe, and most of them are NVIDIA employees. And these people are located across the globe, and they've been accessing these applications day in, day out. So we do see a lot of traffic on these applications, and we have a great user performance issues, and we solve them using RUM.
Great. Thanks. And Kevin, can you also tell us a little bit more about the systems you support and that you maintain and build?
Sure. So Cambia Health Solutions, we're a healthcare company. We've got millions of members across several states through our regional health plans. And the website and mobile app are ways that our users would go for something like to find a doctor in their plan, manage their medications, find mental health resources. So needless to say, crucial that these people are able to access the site when they need it for those resources.
That's great. And Kevin, so after you all started using RUM at Cambia for your websites, were there any, I guess, unexpected challenges in implementing RUM? Thinking about things like either instrumentation or adoption, right? What did you have to do to get, RUM to be successful?
I think that's multifaceted. So we're a healthcare company which has unique challenges to adhere to privacy and compliance standards. We care about our members' privacy, and so adopting new tools, especially something like RUM, where you could say one of the pitches is so that you can see what your users see. That might make some people nervous who are very keen on privacy, which again we care about. So we did make some concessions in that department to at least get RUM integrated in the first place. We knew that real user monitoring was going to bring, highlight some blind spots for us that we didn't have with other telemetry, so it was important for us. So, one way that we compromised, so to speak, was that we disabled our session replay completely.
Okay.
With the knowledge that we could redact content or something, but it's kind of one of those things that if we can have a little give here, it's a little bit easier to get our foot in the door and get RUM implemented in the first place. But beyond the privacy and compliance, there's other things that we made sure that the logging through our front-end systems is still very careful, like we are with all of our sensitive data.
Mm-hmm.
But aside from like privacy and compliance issues, there's just sort of it takes a while for RUM to click, so to speak. Like a lot of people at our company had learned about it. That's why we wanted to adopt it. But there's some. It's one of those things where you have to like experience it for yourself for it to like fully make sense. So there is a little bit of like a propagation of these concepts that is a little difficult naturally.
Yeah, gotcha. We'll get into more of those kind of
sure.
aha click moments
of course.
in a bit. Viswa, so you've told us that you work on your developer experience platform, and you were telling me a bit about some of the challenges that you faced internally with some related to your platform. And I wondered if you could share a little bit more about some of the challenges you faced and how you approached solving those.
Sure. So like I said, these are very crucial applications for NVIDIA, yep. And they are deployed in a hybrid ecosystem where some of the components are on-prem, cloud, and everywhere. Even though they come with their robust infrastructure monitoring, most of the time we do hear complaints from a user about like performance issues, like, hey, the page is not loading, or we were being stuck at this spinning wheel and nothing is being loaded.
Yeah.
So what we realized is whatever we see on the infrastructure dashboards are not actually making sense from a user flow standpoint. So that is where like we were trying to get to the details of like, hey, we really want to observe what user is seeing during accessing this application. Mm-hmm. And we also want to see that across the globe, not just like one region or like from one application page or one application resource. So we enable like RUM to see this holistic picture of all the resources within the web page and how each resource is performing during the page load times.
Mm-hmm. Yeah, cool. And and so after you enabled it, what sorts of unique insights were you able to draw?
Oh, for sure. So first thing is we saw people who are accessing the particular application through a VPN tunnels have like a very significant poor performance versus people who are accessing outside the VPN. Mm-hmm. And along with that, the resources on the page itself took a longer time to load, like some of the examples like attachments or macros. And we also noticed with session insights, especially after enabling the RUM, we were able to see which of the regions have higher impact in terms of performance versus which of the regions have like a better performance. Okay. Along with that, we also noticed the macro integrations within the application or page level integrations are contributing to the overall performance of the application.
Yeah. That's really interesting about the VPN thing.
Yeah,
that would have been like, imagine if you try to identify that without some tooling to tell you. Kevin, you told us a little bit about some of the challenges you had, but you've told me as well about moments where you realized RUM really clicked for you and that opened up new insight that you didn't have before. Can you share that with the audience?
Sure. So I alluded to the fact that this is one of those things where once you experience it the first time, then it's almost like an epiphany, or at least that's how I felt. So during on-call, when it was my turn on rotation last year, we had this repeating issue where some members would call in and say they couldn't log in to the website, which the authentication systems for the website and the app are part of our team's responsibility as well. But this was very important to us, so it spent several months building a robust runbook. We were like, okay, but the logs show that it's successful. The user says it's not successful at the exact same time. So once or twice a month, that's fine. Like maybe somebody just, maybe it's user error, or maybe our messaging on the site isn't clear enough or something. But during one of my on-call rotations, that happened repeatedly. to a point where I was like, I can't just chalk all this up to user error. There's got to be something else, right? Like looking at the logs and our other backend metrics seems like it's not giving me the answer I needed. And I was trying to think, literally, like I'm picturing somebody who is going to this website, who's seeking some kind of medical care, and they're repeatedly trying to get in. I'm kind of putting myself in the shoes of that person. Like, it's frustrating. Some of those people even, they called in multiple times, which, I mean, I'm sure everybody here has had to call customer service at any point. Even the best customer service, like, it takes extra time. Anyway, so I realized, like, what are they seeing that they think that something is failing, right, like in the login? And when I started to think, what are they experiencing, that reminded me that we had implemented RUM, which tells you what the user is experiencing. So once I got a guided tour of that from one of the senior architects at our company, we're able to actually dive into the RUM sessions for these users and saw that, where these logs were saying that things were succeeding, like that they were able to sign in several times in RUM, it showed the same error happening multiple times. So it was the type of thing where an API was succeeding just fine, but right after that, the page just blew up. Like, the front end rendering was failing. So of course, it's not making its way to the back end, so there's not going to be any logs there. So this was just an aha moment that backend monitoring is insufficient for explaining the user experience.
Mm-hmm. Yeah. And would you say that, did you come to find that maybe there were more errors occurring in the application that you didn't even know about?
Yeah. Right. Yeah. So we were glad in the first place just to answer the question of the immediate issue if somebody just called in or multiple people called in. But then finding this kind of unique, it was a Next.js, like React error. Once we saw that specific error that bubbled up, and so the page literally is just like a white page that said application error, check the console. But in RUM, the corresponding JavaScript error, we decided, okay, well, how does that explain some of the other calls that we chalked up to user error? And that was like, a couple times a month, but actually that had just been the tip of the iceberg. But in reality, this error had been happening dozens of times per day. It was tricky. It was, like I said, calling customer service, there's a time investment for the person. So I understand not everybody's going to call, but also this is like an inconsistent problem, so it's very difficult to reproduce. So, again, dozens of times per day over months, and we just didn't even know that was happening until this, sequence of events led us to finally see this information.
Yeah. Yeah, thanks. And Wisła, so after you discovered some of these challenges that were, your users were experiencing slow load times and poor performance, and you're able to kind of learn about some of the challenges related to the VPN, et cetera. What kind of actions did you then take to kind of improve overall developer experience?
Whatever insights we collected from the RUM, we first shared with our leadership. We explained them, hey, this is all the metrics that we have been not looking at so far, because we are more focused on looking at the infrastructure metrics, and we couldn't able to really see what users are experiencing. Now we know what users are experiencing.
Yeah.
We kind of itemized those issues and worked with teams like security team to understand, hey, are you guys okay enabling RUM in first place? If we enable, what are the security components that you want to make sure we enable? And then we work with our networking team to see, hey, is there any betterment in how we can enable VPN-less traffic for these users? And then we also worked with the CDN folks to take advantage of some of the caching for these static objects on the pages. So these action items were taken, and then we saw a significant improvement in performance of the application. Yeah. And I can say 50% of the page load times have been reduced. So that's a good win for us.
That's amazing. Yeah. And then did you get feedback from around NVIDIA and developers?
Yeah, some of the people are extremely happy the way the page renders after we made those changes. Yeah. But still, there are some set of users who still have problems. We are proactively tracking their user workflows, and some of them are using like unsupported browsers, or on like a different version of their clients and stuff like that. So we are trying to proactively reach to those users and understand their problems more in detail and try to solve those ones as well.
Okay, yeah, that's actually a good segue into my next question. So now that you both have been using RUM for a little while now, you've learned some things about your users, their behavior, and especially about maybe where some of the skeletons are laying for your applications. How have your workflows changed? Like, has your development process changed? Like, what do you do now differently that you didn't before you had real user monitoring?
So we have integrated RUM as one of the standard for our deployment process, but not 100% sessions. So we started with like a smaller approach. Like we go to stage, we enable the 15% or 20% initially. Even at 20%, RUM gives us a huge amounts of data. We built custom dashboards, which gives us actionable signals. It's just not you're dumping everything on the dashboard, but you need to make sure the core web vitals, especially the large content paint, time to first byte download, stuff like that. So which gives us the actionable items so that we work with the developers to fix them on the lower environments first before the code gets moved into production.
Okay, that's great. Yeah. Kevin, same question. How about you?
Yeah, so after that first experience where we almost reached for RUM as like a last resort to figure out a problem, we started trying to flip the script and think of it more like an incident response and think of it more like RUM first. So because that first experience showed us like how much more intuitive it is to deal with RUM sessions than it is to try and piece together the puzzle pieces scattered across several different backend like microservices in their logs. Trying to bring those puzzle pieces together from the logs and then kind of say like, I'm pretty sure these relate to the user's issue. Now let's make some judgments. So there's a lot of inferring going on. With RUM, it's really nice that you can kind of start with the user's experience, see kind of more in plain English of like what pages they went to, what things they clicked on, and also get a nice view of like any errors that had also occurred at the time. So whether those are JavaScript errors that you would normally see if I could like remote into their computer, like when my mom calls for tech support, it's like, can I see what you're doing, and can I open like the dev tools and see? Well, and RUM has that, which is a lot more feasible than a one-on-one when you have like millions of members. So anyway, it's really great to start with RUM and then use that to kind of funnel down just to the logs that matter when you need them. Because we've also instrumented APM tracing to connect those two ends, the front end and back end. And just the other part of your question of like what's changed, we're just more cognizant of RUM as a tool. So there's even an incident, for instance, where we had widespread outages where people couldn't log in, and it was very puzzling. There weren't any things that went off. It was just people in the company that just happened to notice. And in that instance, like eventually RUM ended up being like the first signal that we found that would correlate one-to-one with those repeating major outages, and ended up ultimately revealing that it was a back-end degradation, like memory leak. So,
oh, wow.
So it's just one of those things where now we know there's another tool in our toolbox. So, we try and make sure to use that where we can.
Cool. Nice. Thanks. Viswa, what would you say is just to you personally, what would you say was maybe the most surprising thing that you learned along this journey of like doing troubleshooting and then fixing issues? And
yeah, I mean, like once we provision the infrastructure for the teams and application is deployed and we say that, hey, your app is ready, you can go and access the application, we are like, hey, this is good, we have done our jobs. But then on the Slack, you constantly get pings, hey, I'm getting this slow time, I don't know what's happening with my application. The APIs are not rendering the page and stuff like that. So we were like, okay, what is that user is complaining about? Like, can we go and look into what's exactly happening? We used to have a call with them, we used to have a screen share with them and then see what exactly they're doing. But like just Kevin said, with the help of session replays, we were able to see the user actions and where exactly the problem lies with the application. So some of these really helped us to broaden our view with support of an application and bring the reliability factors into how well we can bring the SLOs that everyone agrees upon. Right? Because from an SLO standpoint, we say like, hey, this is 99% available, but user complains, I don't care about your 99, but my application is not loading. Yeah. So we are trying to bring these cohesive approach of collecting everyone agreeing upon the same number of SLOs, and that's where the RUM is really helping us to drive our actionable alerts and actionable tasks to accomplish those SLOs.
Yeah, great. Kevin, how about you? Like, what have you personally learned as you've worked through some challenges at Cambia and kind of resolved these, kind of given some of these new signals and tools that you have?
It's a very different way of thinking about problems. Like I mentioned epiphany earlier, it wasn't to be hyperbolic. It's like you really start to realize like you can kind of think about the user experience differently, or at least like looking into problems that users report. I think what it's helped with majorly, in my opinion, is to give context to the problem that's being reported. Like, for example, we get, like, because we own the authentication systems for the website, we get calls about like, my sign-in is failing. So if Bob calls, says sign-in fails, it doesn't mean literally that's the only thing he tried was just he put in his username, password, and hit submit. Like, that may not be the only thing he did. Because if you put yourself in Bob's shoes, if your sign-in fails, you probably then did it a few times. You might have also gone to account recovery to try password reset. You might have even, again, with the notion of calling customer service being extra time investment, maybe you tried it like 2 weeks ago and maybe like last weekend, and then you tried again and now you're calling. So all of that extra context really helps for when we're looking into the incident, because then we know whether this was like a one-off or if this is something more consistent. Anyway, so it's great to be able to get that context through RUM that it's again is really difficult to do with logs, like trying to do the equivalent of looking at all those APIs that are in charge of like different account recovery pieces and login over like, say 2 weeks even. It's just kind of overwhelming. So RUM simplifies it and gives the extra context.
Yeah, giving context seems like a common topic today. I'm looking at you, MCP. Great. So Kevin, where do you see the biggest ROI for having adopted RUM? I think specific for Cambia, just like what do you think overall has been the biggest ROI, and is it performance, is it customer experience, or something else?
Good question. I know that we are using RUM tooling to try and measure and improve front-end performance. So certainly that is a crucial feature. I mostly could speak for myself and for my team that the ROI that I think we've gotten is that trying to build that kind of context of, This is a non-mathematical viewpoint, but I feel like when we receive an incident, like 70% of it is just interpretation and getting context.
Yeah.
Before you ever try and like hypothesize on like why it's failing. So RUM is just, it's been a lot quicker for us to get that kind of context. So, you know, it saves us hours or days, I think, and gives us higher confidence in many cases than the inferences we have to make with other tooling. So
yeah, thanks. And how about you, Viswa? I know, having been a developer, we have strong opinions about experience. What would you say has been the ROI for NVIDIA and developer experience?
For sure, like we were able to like lower the MTTD and MTTR in the first place. That was a huge win for us. We really want to provide a best experience for developers rather than they being on call, troubleshooting what's going on with this issue. But with this enablement of RUM along with APM and logs, the seamless navigation between the problematic pages back to the logs, application logs, helped us to detect these problems way ahead and have us being in the more proactive side of solving problems rather than reactive side of it. And that's a huge ROI for us rather than really thinking in terms of like money or anything else. So that number, that MTTR improvement is really a good achievement for us.
Yeah, it's nice to have something measurable.
For sure,
that
yeah.
you can take to the leadership, right?
Yeah.
I forgot that we actually looked up the MTTR improvements from when we started using RUM in incident response, and I believe it was like around 20% reduction or something. But that's a good call out, MTTR improvement.
Yeah, we definitely track those ones,
Yeah, that's great.
Nice. Okay, so I think I'm supposed to stop at this point and ask the audience here if anyone has any questions for Viswa or Kevin.
We got some microphones in each aisle. Yeah, if you have a question, come to a microphone. That way everyone can hear your question. They're right there. Thanks for pulling up the lights. Otherwise, I will be making up questions for the panel. Don't want that.
Okay, cool. Yeah, thanks for all of that, by the way. It was really informative. I walked in a little bit late, so I don't know if I missed maybe what this might have answered my question already. But I do work with user behavior in my field, which made me really curious about what Kevin described, where he was finding a pattern in the errors being very constant, to the point where he was hypothesizing and he flagged a larger issue that was actually going on. And so as someone who is learning more about what Datadog does and its capabilities, does Datadog have a plan to maybe use AI or any sort of way to speed up that process of flagging like a consistent type of error and then figuring out or being able to tell your developer what the underlying issue might be?
I'm interested in that, actually.
Oh, gosh, is that a question for me?
Yeah.
Did you attend our keynote earlier?
No, I didn't. I came like an hour-ish ago.
Okay.
They did talk about AI a little bit.
Okay, very cool.
Yeah, in short, yes.
Yeah. Okay.
But
very cool.
Yeah, maybe we can talk more about that after.
Yeah, okay. I had one more question.
Of course.
What is your current process for kind of understanding and innovating the developer experience? Like, do you have a dedicated team that's like working with a lot of your clients on studying like the developer behavior and what kind of things they're looking for? Which was maybe also answered.
It's for me, okay. So we work with both developers and also the customers who use the product. For us, when a developer comes to us for an SRE support, we kind of looks for how the product is qualified to provide an SRE support or not. Some of the qualification metrics include it should have a proper logging mechanism, it should have a proper tagging strategies, it should also have a proper setting configurations for RUM and APM. So once we have all this in place, we really want to perform that testing on the lower environments. So when we do this stress test and load test on these applications, we kind of closely monitor where the application is kind of breaking and what is the limitations of the application. So if it is like a P0 thing that, hey, we want them to go and fix it immediately ASAP. But if it's something like it's a P1, P2 issues that they have already planned in their deployment lifecycle, so we kind of allow them to go into the next environment to test. But all of these applications go through a strict security review process so that we are not leaving any leads.
Okay. All right. Thank you so much.
Thank you.
Kevin, do you want to speak to that last one, or?
Sure. So we have a fairly large team that's in charge of developer experience, and then we have community practices to try and socialize across orgs, even to have standards in that area. Some things off the top of my head have to do with consistent service ownership responsibilities, and which could include like types of monitoring to add and alerting, and yeah, just some processes that have to go with that. We're a fairly large like enterprise company, so it's a very like formulated thing, but does evolve over time. So
I do have a question for the three of you. You have a magic wand. You can wave it, and you can make one RUM-related problem or innovation, either problem go away or innovation happen. What do you want to change? What do you want to add or fix?
I think I need 2 magic wands.
Oh, yeah, no, I found a second one.
Oh, thank you. Yeah. So one is just that signal to noise with RUM errors it's very difficult to weed through. There's a lot of like front-end errors that don't actually represent an impact to the user experience. So much of the time when we add something that's trying to be proactive, it's actually because we were reactive at a certain point. So we know that, you know, like earlier when I mentioned that front-end error, now we know that this particular kind of error message does have a tangible impact to the user, so we can listen to that. But at that time, I got a little gung-ho, and I was like, okay, well, what other errors? What's the most frequent, like 10 errors that we have in RUM? And so many of them didn't have a clear like correlation to what a user would see. Might have been like on the side, like maybe React was like, hey, you're supposed to add IDs to those elements, or something like that, you know. The other magic wand, something that I'm actually still trying to work to a solution on, is a very smooth process for unauthenticated experience, and tying that to specific users. We're pretty well versed in how to do that for the authenticated experience, because we have like, you know, user IDs, or at least surrogate user IDs for those. Unauthenticated experience, we do have anonymous IDs and you know, tie the session together, but there is a lot of kind of like manual work of, we have to kind of like make contrived session IDs on the front end and have those same ones on the back end, so that there's just a couple of extra steps if we're dealing with something that's unauthenticated. So I feel like there might be some opportunity to streamline that, especially because I think some of our APM data for, you know, at least certain types of like almost authenticated parts of the site, you know, may have information that would be nice to have in the RUM session as well.
Yeah, similar thing. Actually, Kevin stole my thought process. We do have the same problem with the RUM and the APM. Tagging them sometimes is very hard for us. We do see trace IDs for some of the events, but we cannot really correlate them with the front-end RUM events. So we need to really time lock and ask user, hey, can you run this test one more time for us, please? And we kind of captured that event and then time box the same logs, APM, everything in the same state, and then we try to derive some sort of issue with the application. Maybe something we might not be doing it right, I don't know. But other thing is, in future, what I want to see from RUM is ability to seamlessly integrate with SaaS products. Today, most of the SaaS products, they don't really allow this custom SDK ingestion into their headers. We need to build some sort of wrappers around it and then try to collect some metrics. That is something, if in future, if it's available, it will be much more useful, because like I said before, RUM has been one of our standard now. Anytime you're throwing your application to the customers, you better make sure you capture those RUM events so that like we are all on the same page.
So you guys now are real RUM power users. If there were anyone here who either is thinking about trying RUM or maybe is like a new user, what's one thing that you would suggest? Like, what advice would you give that person as like a brand new user, something to check out?
Yeah, for sure. Like when we started with RUM, we kind of enable like 20%, but then we don't know what to do with the data. So then we try to like trim it down to one specific use case. Like let's focus only on the page load times. And we took that use case, we tried to see what are the different flame graphs, why a page load is at a certain number. Like we try to drill down each layer, like and try to work with those teams to improve that layer. So my suggestion is, if you're starting with the RUM, start with the smaller number and try to focus on solving one problem at a time. That should really help us to gain more insights and understand what is your next problem to be solved.
Great. Kevin?
So I think I kind of have two. The first one is check out RUM without limits, because then you're going to have some benefits of like aggregate data without, going over costs maybe if you only want to retain more detail on only certain kinds of sessions. My other thing would be to, in my opinion, don't go with just RUM. Like, also include application performance monitoring, APM traces, because it was a game changer once we instrumented the APM tracing in RUM, as well as, like, we'd already had it in our logs, but then at the point that we added it to RUM, what that meant is we could look at a user session, try and like kind of surmise like what story surrounds like this activity, but then just literally click a few times and now you're in the corresponding logs or in the other APM related data. So it's much better than what we did for a little bit before that, which was have our own IDs and try and like manually search by like request IDs that we defined in different areas.
We got time for one last live question.
Oh, sure. Hi. So this might be wide-ranging, but I'm curious, outside of errors, are you using RUM at all to like determine what features to develop, or like sharing data with execs, or like monitoring adoption, or things like that?
You want to go first?
Go ahead.
Yeah, sure. We provide some default dashboards to the users, especially most of the time the business is interested to know how many users or how many active users are using this application at a given time, and how much of these are having frustration signals. So that really drives the business to help on adding up whether this is a feature that they want to work on, or this is a feature they want to hold on for some time, or this is something like this service need to be sunset and try to completely build in a new architecture. So some of these insights will help by enabling after we enabled RUM. So there was a huge percentage of people look for, hey, is my application really that slow, or is it being bottlenecked by a network layer, or is it because my application is performing well, but I don't know whether its database is not able to respond at the given time. So all these sort of insights are available with this feature. But at that point, we kind of leave it to the business teams to decide on what features they want to enable. But some of these insights really help them to have their sprint plannings planned accordingly to improve the application overall performance.
Oh,
Kevin, do you want?
Actually, the thing. So I deal with errors and like incident response a lot more than trying to be a proponent for new features. Although that is, it's important and definitely happening at the company. My answer actually would be there was a really great talk by Eric Song at the last Dash from a couple of months ago, which is on Datadog's YouTube channel. So, and he did go over how that helped with their retail company, and him showing some more like traditional upper management why something is important, and when they tried something new, how much better it was based on real, user metrics. So.
Yeah, don't forget to like, follow, and subscribe. No, sorry, wrong outfit. Please give our panel a huge hand of applause.
Thanks.
Cool. Thank you all.
All right.
Thank you.
Thank you.
Guys. Thanks for coming.